Hello everybody and welcome to our show today. My name is Keith Bogart and I'll be your instructor for today's session. And as you can see, our title of today's session is Introduction to Networking Technologies. So let me just, for those of you who have not taken a show from me before or taken any of my classes, let me just real quickly introduce myself to you, so I'm not a complete stranger. My name is Keith Bogart, and I've been a technical instructor and course developer here with I&E for about almost 3.5 years. Prior to that, I actually worked at Cisco Systems as a technical instructor for them for about 12 years. And before that, I was also at Cisco Systems in various other roles like technical assistance, network consulting, and various other jobs. So it's my passion to teach people CCNA and CCNP and even CCIE level technologies. By particular, I have a real passion for teaching like the NA and the NP level for people who are just starting to get into it and seeing their eyes open up as they start to grasp these new technologies and the things that seemingly were impossibly complicated. All of a sudden they realize, oh, it's not as complicated as I thought. So during the show, you'll have plenty of opportunities to ask questions, and I want to talk about that in just one moment. But once the show is done, if for some reason you had a question that did not get answered, or if you have a question after the show, you can see my contact information right here, so you can reach out to me. Feel free to ping me with any questions that you might have. In addition to that, I want to show you one other place that you can post questions as well, which leads me to go to I&E's main website. And I just want to point this out to you here. If you're an I&E customer, and what I mean by that is simply if you have an I&E members account, which is free to do, this month, October, we are having a promotion. And if you go to the top of our webpage at INE.com and you click on training bundles and free t-shirt, you should see a promotion that we've got going on here. Now this actually is not the promotion I was thinking of. There must be another link to it somewhere else. But I also want to mention this as well. For a very limited time, we've got 33% off on the various courses and stuff that we have, and you get a free t-shirt with that. And if I can find the other link to the other promotion, I will show that to you guys later. But if you go to members, actually let me just start with INE.com. If you click on login, if you're not already an I&E member, you'll be prompted to register. And registering is easy. You don't need a credit card or anything like that. All you need is your name and email address, and that's it. And then you get into our members account. So I'll go ahead and log into the members account here. And there's a reason I want to show you this. It's not just marketing or something. So if you ever have any questions about this show or just studying for your CCNA, studying for your CCNP, or just networking in general, we have this great tool in our members account, which if you go to the upper right corner, you'll see right here where it says Connect, right there. And if you click on Connect, you'll see a link to I&E's online community. If you click on that, that'll take you to our online forums. And if you have just questions in general, like at the CCNA level, and I'm assuming that if you're watching this show, it's because that's probably the level where you are or where you soon will be, is the CCNA level. You can just click on Cisco CCNA and click on the second one down, which says CCNA. And then from here, you can scroll through to see what other types of questions people have asked, or you can create a new discussion. So the reason I point this out is because after the show is done, if you have any sort of just general questions about networking or the CCNA or anything like that, I would actually prefer that you post your questions here, because not only do you have the opportunity to have thousands of people see your question, so you'll get an answer very, very quickly, but the question and the answer is also available to other people. So you'll be helping other people out as well who can learn what you've learned by posting it. Now, in the very rare situation where you might post a question here and a day or two goes by and you get no response, well then by all means, feel free to reach out to here via my email address or via Twitter or via LinkedIn and just send your question directly to me. But I prefer that you go through the I&E online community first. All right, so let's talk real quickly about the course objectives and then some specific things are related to YouTube Live and how we're going to sort of manage this whole thing. So what are the objectives of today's session? Well, for those of you who are thinking of pursuing a career in computer networking, but you're still investigating, you're not sure if that's the right move for you, you're not sure what's involved, you don't even really necessarily know what a computer network is. You might know how to take your laptop and connect it to a network with a cable, but you really have no idea what's going on there. And some of the most basic preliminary concepts and acronyms behind networks, you have no clue what that is. This course is for you. So I'm going to introduce you to computer network. What is this thing called a computer network? What are some really common components that you'll see that make up a computer network? When you hear these terms like routing and switching and data center and wireless, what's involved with that? And how does that translate into job opportunities? Someone who specializes in routing, what are they actually doing in a day-to-day basis, as opposed to someone who specializes in switching or security? We'll talk about that. I'll also talk about some potential job roles. So by the time you're done today, you should have a fairly good idea of, what's the difference between a network administrator and a network architect. They're two vastly different roles. What are they, and where would you probably fit? And as far as a network administrator is concerned, which once again, because you're watching this show, I'm assuming that if you do move into the role, into the computer networking industry, that's probably where you're going to start, is as a network administrator. So I've got some brief material here on just some samples of starting salaries for network admins. But keep in mind, it's very, very subjective. Like, all the information I gathered was based on the United States. And I was watching you guys, it seems like you're all over the place, Slovakia, India, all sorts of places. So the salaries that you might expect in your local market will be vastly different than what I'm going to be showing you here. So that's my objective. So the course overview is, I'm going to talk about what is a computer network. Then I'm going to go into the components that make up a computer network, not to any great detail, but just to, feed your appetite on that. Some technologies that comprise a network. That's where I'm going to talk about what is routing, what is switching, what is data center. Talk about that. Talk briefly about network job roles. What's the difference between a network engineer, a network administrator, a network architect? I'll sort of paint a picture for you there. Some computer networking job specialties. And then lastly, we'll finish up with, where do I go from here? What's my next step? So that being considered, let's talk about this from the perspective of the delivery mechanism right now, which is YouTube Live. So I've found through experience that the best way for me to take your questions is, once I'm done with a specific section, and a section will go anywhere from like 15 to maybe 20 or 30 minutes, then I'll take a break and I'll take Q&A and I'll look at your questions and I'll go back to the next section. So what that means is, as I'm teaching, as I'm lecturing you guys and giving you stuff, by all means, feel free to type in your question and other people have the opportunity to see it. Just know that when it's time for me to get to the Q&A, it just takes far too long and you guys would be bored out of your mind if I have to scroll and scroll and scroll and scroll up through all the questions that were submitted over the past 20 minutes trying to find those ones that weren't answered. You don't want to do that. You don't want me to do that. So what I would say is, feel free to post your questions as we're going along. And as I'm going along here, other people will hopefully answer them for you. Now, if by the time we get to the Q&A, either you haven't got an answer yet, or you haven't had a chance to post your question yet, then go ahead and put it in there. And that'll be, for me, a fresh question. I'll see it right there at the bottom of the screen, and that'll give me the opportunity to answer it myself. Just be aware that during the Q&A, I'm not going to scroll up looking for unanswered questions, because that would just take us far too much time. So that's sort of a logistical thing right there. So as far as this course is concerned, do we have any prerequisites? Well, the answer is no, we don't. Really, it's just you have to have a computer. You have to be able to see and hear me, and the fact that you're watching right now, there you go. You've met the prerequisites. So I'm going to assume that you have no networking knowledge at all going into this. So we're starting at ground level 0 here. We've already talked about Q&A, and I've already given you my contact information. So with that, let's go ahead and go into the first section. So first section, what is a computer network? And these are the parts that we're going to talk about right here. These are the objectives of this section. Okay, so what is a computer network? You know, many times when you throw the term computer network at people, they envision some monstrously big thing. It's, you know, they can't really tell you what it's made of, but they say, well, it's big, it's complex, it's a lot of devices. Well, it can be, certainly, but technically speaking, a computer network can be as small as just 2 laptops or 2 PCs connected together with a cable. That's a computer network. I mean, by definition, a computer network is a combination of software and hardware that allows 2 or more devices to communicate and send data between them. So like I said, it could simply be 2 laptops connected by a cable running the appropriate software, which is by default built into Windows and built into Mac OS, so they could talk to each other. That is a real simple computer network. Now, most computer networks that you'll find these days, though, probably don't fit into that category. You know, that's like if you're at home and you're, you know, doing gaming, or, you know, you and your wife have your laptops connected to each other. Most networks look more like this. So now we're going to focus on what I would call an enterprise network. So the term enterprise network is, what does a network look like at an office, at a building, at a company? Okay, so a company has their own internal network. What does that look like? Well, we're talking about more devices, right? Not just 2. So like here, we've got several devices, several laptops and PCs that people need to communicate. And chances are that that enterprise network is going to have to be subdivided into different departments, right? We're going to want one network for maybe all the payroll people, another network for the human resources people, and we want to separate them. In other words, the stuff that payroll is doing, well, that's kind of sensitive, that's kind of secure, and you know, maybe we want payroll to access the human resources web server, but we don't want the people in human resources to be able to access the payroll web server. So we can't just string out one cable and have everybody connected to that one cable, because then they'd all be on one network, and regardless of whether they're in payroll, engineering, marketing, human resources, they would be connected to one network. They'd all see everything. So we want to subdivide this. So, you know, a very simple way might be where we have, you know, back when networks were first developed back in the like 1970s, it was literally one cable. And then, you know, they didn't even have laptops or PCs back then. We had these big mainframe computers, right? And a mainframe computer would have an adapter. The cable would run through it, and the adapter would sort of bite into that cable, right? Because every cable you look at pretty much looks the same way, right? Every cable has some sort of outer covering, which is like, you know, plastic or rubber or something like that. And then inside of it is where you've actually got the copper, the metal of the cable that's carrying the electrical current. So back in the old days, in the 1970s, you had one thick cable going through mainframe computer, and each one of these computers had an adapter that would bite through that plastic or, you know, rubber coating and go into the copper in the middle. So you literally had all sorts of devices tapping into this one physical cable. So that's sort of like what I'm showing here in this picture, Department A and Department B. You know, imagine these people are back from the 1970s, and they're all connected to 2 distinct cables, 2 different networks. Now, very quickly they realized that, okay, this isn't really working all that well, because with that type of cable, with that type of network, you see, if you were going to design a network, if you said to yourself, okay, I want to create a brand new network that doesn't exist, and it's going to be my baby, my invention, I'm going to become rich and powerful and famous from it. Well, you have a lot of questions to answer. For example, number 1, when a laptop or a PC connects to that network, physically, how is it going to connect? Are you going to use copper cabling like exists today? Are you going to use fiber optic cabling that uses laser lights or LEDs to send the data? Are you going to use the air like Wi-Fi does? Maybe you'll create a whole new network that uses water, right? Something connects to a stream of water, you know, something, but you got to connect to something. Then the next question you'd have to ask yourself is, well, by definition, a network is 2 or more devices connected together. So the next question is, well, when device A wants to communicate, when device number A wants to send data, is it going to be allowed to send data whenever it wants to? Or does it have to first test the network to see if the network is available, if it's idle, if it's free, and then it can send its information? But if the network is currently in use, it has to wait. Well, that's a question you have to answer. If you're designing a brand new network, how are you going to do that? So how does that relate to this? Well, back in the early 1970s, when networks first came out as this one physical cable that everything was literally connected to, the designers of that type of network, they said only one device can talk at a time. So if two or more devices start putting their electricity on that cable and sending their data, that's not allowed. That's breaking the rules, and those two devices won't be able to talk. They'll have to stop and then randomly try again when the network is free. So that method worked at first when you had 2, 3, 4, maybe 10 devices connected to that cable. But the more and more devices that were tapped into that cable, once you start getting up to 15, 20, 100 devices, that didn't work so well. Because now your device would be like, hey, I can't send my data. Every single time I listen to that cable, there's always electricity on it. Somebody's always talking. I can't get on. Or your device would complain saying, hey, every time I put my information on that cable, it's running into somebody else's electricity. It's not working. So they said, okay, instead of having everybody connected to one physical cable, why don't we do this? Why don't we give each laptop, each PC, their own unique independent cable? So now imagine we got all these cables here connected to laptops and PCs, and we'll have all those cables connected to one central networking device. And that's called a switch or a bridge. And originally it was a bridge, and then nowadays we call it a switch. And so the idea behind this is that, okay, if my laptop has a cable connecting to the switch and your laptop has a cable connecting to the same switch, well, if we were connected to the same physical cable, I could talk, you could talk. I could talk, we'd have to take turns, right? But now that we both have separate cables connected to this one central device called a switch, literally, you can start sending your electrical energy, your data, at the exact same time I'm sending mine, and that's not going to cause any problems. Now you might ask, well, why? Well, because that switch has memory. It has computer memory, just like your laptop, your PC, your tablet has memory. And as that electrical signal is coming into the switch at the same time, the switch says, okay, I'm going to store this information in one part of memory. I'm going to store this information in a separate part of memory. And then I'll let this one go through, and then I'll let this one go through. So even though they're coming at the same time, this central device called a bridge, or nowadays a switch, made that okay. It made that acceptable. It had memory inside to make that work. Now this slide here is also showing, if you watch the animation, that as networks evolved, people started saying, well, what else could we connect to this network in addition to laptops and PCs? Well, let's see. Right now I got a telephone over here. And this telephone is connected to a completely different wired network. It's connected to AT&T's network or Pacific Bell's network, but it's connected to the phone company's network. And I'm paying a totally separate fee for that. Wouldn't it be nice if I could get rid of that monthly bill and take those phones and connect them to the exact same network that my laptop is connected to? Then I can save myself money, and I'm in charge of it. If something goes wrong, I don't have to get them on the phone and hope that their customer service will fix the problem. I can fix the problem. So in today's networks and most enterprise networks, your phones are what's called IP phones. In other words, the phone is connected to the same network as your laptop, as your PC. It's connected to a cable, it's connected to a switch, just like your laptop, just like your PC is. So that was sort of the evolution of networks. Now, in this particular environment right here, whether we have Department A and Department B all on one physical cable, or if we have them all connecting to the same switch, like we see here, they're still technically all on the same network. In other words, Sally over here in Department A, when she sends data, there's a very good likelihood that everybody's going to see that data. Now, of course, it depends on the nature of the data, but once it comes into the switch, everybody's going to see it. So some people said, that's not good. I mean, after all, the people up here are in payroll, and the people, I should change that. Sorry about that. The people down here are in human resources. Okay? So we don't want Sally right here, her data being seen by human resources. And yet if she's connected to this one switch just like everybody else is, she'll see it. Everybody will see it. So let me back up here for just a second because I realized that my wonderful face here was on full screen, but this slide was not. So let me just go back real quick and just real quickly recap the animations. So here we had the two separate departments. Department A was connected to their own cable. Department B was connected to their cable. And we said that doesn't work when we start having 20, 30, 40 employees. They're running into each other. So then we said, okay, let's add the switch into the mix, right? So this is where they're getting their own separate cables connecting to the switch. And then we said, let's add IP phones onto that. So now we got the IP phones connected to that switch. But at this point, we have a problem. Everybody's seeing everything. There's very little security here. Very, very difficult to isolate this department from that department because they're connected to the same switch. So then somebody said, oh, well, wouldn't it be nice if we came out with a device that had the ability to segment networks and where we could implement security on that device. So on that device, we could control, oh, Sally can talk to payroll if she's just doing web browsing, but she can't talk to payroll if she's doing something else on the network. So that's where a router was invented. And so a router is typically shown in networking diagrams as a sort of hockey puck type thing right here. So the router is connected to the network via a cable, just like the laptops and PCs are, but the router serves a much different functionality than the switch, right? The switch's main job initially, when it first came out, 2 or 3 decades ago, was, hey, let's just get people off this one common wire and give each person their own dedicated wire. That was the main function of the switch, of the bridge. The router's functionality was, hey, let's now be able to have everybody on a network but segment them. Implement security policies that says, okay, this group of the network over here can only talk to this group if they're sending a certain kind of data or if they're doing a certain kind of thing. So that was the role of the router. Now also as networks evolved, wireless networking came into play. So your laptop or PC might have a wired connection, but chances are these days you probably don't have a wired connection. As a matter of fact, a lot of stuff that's coming out like Chromebooks and things like that don't even have the interfaces to connect a physical wire. There's nothing to plug it into. Most things these days are definitely moving towards Wi-Fi. And by the way, don't let anybody ever tell you that Wi-Fi stands for something. A lot of people are first learning about wireless think, oh, Wi-Fi stands for wireless fidelity, like high fidelity in the world of stereo. Wi-Fi does not stand for that. Wi-Fi doesn't stand for anything, okay? It's just a name of wireless networking. So a lot of devices these days have a radio built in. And it's much like the radio in your car, but here's a common difference, right? The radio in your car when you're driving around, it has the ability to receive radio signals, right? That's why you can tune into different radio stations and listen to country music or rock or pop or whatever it is. All that stuff is going on around you all the time. And the radio in your car is able to selectively say, I'm going to filter out all this other stuff and just tune into this one station and present this country music or this pop music or whatever. But what's one thing that your car radio cannot do? It can't transmit, right? You can't talk into the car radio and have it send something out on the radio waves. All it can do is receive. Well, the radios that you have in your laptops and your tablets and your PCs, we actually call those radios transceivers, right? The radio in your car is a receiver because all it can do is receive. The radios in your laptops and PCs and tablets are transceivers. They can transmit and receive. So that's what we have going on here. So you've got a transceiver, in other words, a Wi-Fi adapter in your laptop, and then that communicates to a networking device called an access point. A lot of times they're just called Wi-Fi APs. So the access point is the thing that's transmitting data to you, so you can receive your web pages, receive your emails, and the access point is also has a transceiver. It can receive data from you when you send an email, when you do instant messaging or something like that. And then the access point in turn is connected back to the network via physical cable, via a switch. So in most corporate enterprise networks these days, and even home networks, you probably have a combination of a wireless network, like we see right here, and a wired network, and they're all connected together. And typically somewhere in that network is some device that's acting as a router, that's implementing security policies, keeping things separated from each other, as well as a whole host of other things. Okay, now as networks evolved, right? So back in the day, it used to be, let's go back here for a second. So here we had Department A and Department B. Now Department A, back in the early days of networking, what was it like? Well, the initial days of networking was what's called sneaker net. You're probably never going to hear that term. What does sneaker net mean? Well, if you're, 40 years old or older, maybe 35 or so, you might remember the days of floppy disks. Remember that? Floppy disk drives, where you would save your information on a little diskette that was about the size of this. You would pull it out of your computer. Sneakernet meant that you put on your sneakers, your running shoes, and you walked over to Sally and said, here's my data. Technically, you, the human being, are the network, because then Sally would put that floppy drive into her computer, and now you've exchanged data. So they called that sneakernet. Then they invented a cable that connected your laptops together. Now you could transmit data without walking, without using that floppy disk drive. And so at that point in time, all the data was on your laptop. And then some people said, well, that's not a great idea, because if I'm keeping very sensitive, very important information strictly on my laptop, like maybe all of my human resources information, my files, my payroll files, what happens if my hard drive crashes? Now I've lost all that information. So people start saying, maybe it would be a better idea if we had a special type of computer that had a lot of memory, very big brain, very big CPU, and we stored all of our data on that. And that's what we call a file server. A file server is a computer like your PC, like your laptop, but what makes it unique and different is it's got a whole lot more memory than your laptop or PC does. And its processor, which does all of its, applications and software, is typically a lot faster, a lot bigger than the processor in your laptop. So some people said, okay, let's take all of our information and put it on a server, and then we'll access that information via the network. That way people can access it from anywhere at any time. Oh, and let's have a second server that backs up the first one. So just in case the first server goes down, we've backed up all that data across the network to a second server. So initially, these servers would be located in the various different departments. For example, Department A, they would have a server right here. They had all their information. Department B, they'd have their own server right here with their information. But as that evolved, it started getting difficult for the network administrator, right? The administrator was the one who monitored this network, who fixed the problems in the network. And if Sally from payroll said, hey, we can't get to our payroll records, then the network administrator would have to say, okay, do you know where your server is? Because I got 5 servers over here in this part of the building from marketing, 5 servers over here in payroll. Oh, and by the way, they're not all in the same place. There's one over here in John's cube. There's one over here in Larry's cube. There's one upstairs. So people said, well, why don't we take all these servers and put them in one place? Let's dedicate a room in our network. We'll lock it up. We'll make it really secure. We'll put a lot of air conditioning in there because these servers generate a lot of heat. And we'll take all of our data, our mission critical data, and we'll put it in one central place, one center location of our network. And so that, when you hear the term data center, is what it is. So a data center is a location in the network, a very secure room, a lot of air conditioning that has dozens and dozens and dozens of servers all centrally located. So payroll servers are in one rack right here. Human resources servers are in another rack right here. So you don't have to go hunting them down. They're not spread out all over the place. They're in one central place. It's locked down, very secure, very easy to know exactly where they are. So that's another portion of the network, the data center. Now that's probably at your house. You probably don't have a data center at your house, right? All of your information is probably still located on your laptop or on your PC. But in larger networks, that's not secure enough. So now they move all that information to servers all in one place in a data center. And then there's one more component of a network. Now, this is all well and good if this company just wants to exchange information with their own employees. Payroll just needs to talk to marketing. Marketing just needs to talk to engineering, right? That's it. But what do we have now? What have we had in the last couple of decades that's super, super popular? The internet, right? Somebody had some great idea. Hey, wouldn't it be great if we could take all the information, or maybe select information from this university, right? There's this university here, and their physics department, their biology department, they want to share the stuff that they're researching with this other university, or maybe this government institution. And they said, we should figure out a way to have a network in one company or institution communicate with a network in another company or institution. And hence, the internet was born. And so today's networks have some sort of connection to the internet, and they connect via an internet service provider, which you'd commonly think of as like Comcast or Sprint or Time Warner Cable or Spectrum or something like that. So an internet service provider is somebody who says, hey, we will run a cable to your house or to your business so that your network can connect to the billions of other networks that are out there, and now you can start sharing information with other people's networks. So your router would typically have some sort of cable connecting to the internet service provider. So that is a computer network. So to rehash once again, it could be as small as just 2 devices connected with a cable and that's it, or something as large as this, with its own separate data center, its own separate Wi-Fi, a voice network with your phones, a data network, all connecting to the ISP. Now let me talk about some common vocabulary that you'll see when you start investigating networking. LANs versus WANs. So a LAN stands for a local area network. So for example, if I go back here in this drawing right here, all of this stuff here is a local area network. So a local area network is typically defined as a network that you control. So you as a company, you control this network. You own all the devices, you own all the cables. It's completely up to you what goes on this network and how this network operates. That's a local area network. Also, a local area network is usually pretty restricted in its distance, its size. For example, from one end of a local area network to another end of a local area network might be as small as 5 feet or 2 feet, or it might be as large, a local area network could be as large as, I don't know, maybe a block or two, a city block or two. You know, imagine, for example, a company that has 15 buildings, and those 15 buildings start at one block and end at the end of that block or at the end of another block. And they actually have cables connecting one building to another, or maybe they're using wireless to connect from one building to another. Well, technically, that entire network is under their control, under their domain. That is their local area network. Now, when you connect to the internet, like this section right here, that goes by the term wide area network. So a wide area network is a network that is not owned by you. You rent it, you lease it. Somebody else like Spectrum, Time Warner Cable, Comcast, they own that network. They own the cable, they control it, and they rent it to you, they sell it to you so you can connect to other people's networks. So WAN covers vast geographical distances. For example, there are literally underseas cables that stretch the span of the Atlantic and Pacific Oceans that run for thousands of miles that connect one device to another. That is a wide area network. Networks that communicate with satellites into space. That is a wide area network. So those are a couple of terms right there that you should be familiar with. A node or a host. So any device that connects to the network, and I would say this device is either originating data. So, you know, there's a human being on this device and they are creating data. They're creating an email, a website, sits on that device, or a device where data is terminating. For example, in my network, if my laptop is trying to communicate to the web server in my network, I'm trying to bring up the I&E web page. So there's some server in my network, it might be 20 feet or 100 feet away from me, and I'm trying to get to that server to get the data on that server. So I'm sending a request that's terminating on that device saying, give me the data that you have. That is considered a node or a host, a device that connects to a network, and that device is transmitting data or transmitting requests to get data. That is a node or a host. So for example, laptop, PC, smartphone, tablet, those, a server, those would all be examples of nodes or hosts. Let me make a further distinction there. Those I would really call hosts. They could be called nodes as well. The term node more likely refers to a networking device that's responsible for getting that data on its way. For example, a router, a switch, an access point. Well, that's normally when we think of those devices, we think that data is coming into that device and going through that device. That's more of what a node is. So a node is a device that implements the network, that facilitates the network. A host is a device that's connected to the network, that's using the network to send data and receive data. Local versus remote resources. So these days, when you open up your laptop, probably, if I was just to take a guess, I would say probably 80% of what people do on their laptops and tablets these days are making use of what's called remote resources, which means the data that you're getting, the data that you're asking for, is not locally right on your laptop. It's remote. It's located on some web server somewhere, some email server somewhere. In other words, if I did not have connectivity to the network, I could not get that data. So a remote resource is something you're trying to get to that's not physically on your laptop, that you need the network to reach that information, as contrasted with local resources. For example, when you open up Microsoft Word or Notepad and you're creating a document, that is something that's right there on your laptop. You don't have to be connected to the network to type up a document in Microsoft Word or Notepad. There's no networking involved in that. That's considered a local resource. If you're connected via a physical cable, like a printer cable to a printer, your printer would be considered a local resource. It's physically connected to your laptop via a special cable. Now, if that same printer, if the only way you can get to it is via the network, right, via Wi-Fi or something else, well then that same printer would now be considered a remote resource. It requires that you use the network to get to it. And then of course I think I've already defined what the internet is. The internet, simply speaking, is just a collection of networks around the world that are connected together, that can talk to each other. So that is the internet. So when you're accessing the internet, what you're doing is you're accessing the billions of other networks out there in the world that have opened themselves up so you can get their data and they can get your data. That's the internet, a collection, a spider web of billions of networks. That's why it actually used to be called the World Wide Web, because like a spider web of all these networks connected together. So why do we need computer networks? You probably have some ideas as to this, but the basic idea about networks is it allows us to share things, right? It allows us to share files, programs, and resources. Files, right? A file is I'm sharing data. For example, without a network, you can't do email. An email is an example of a file. Without a network, I can't send you a music file or a video file. So that's data, right? Sharing data, sharing files. What do we mean here by sharing programs? Well, for example, a lot of times the way things work is that I could connect my laptop to the network and Maybe I want to run a particular program to do something. For example, here's an idea. Now, I am not a meteorologist, right? But from what I've heard, the programs, the applications they use to do this weather modeling, to model, where a hurricane's going to go, or to do weather predictions, are super intensive. These are programs that consume like massive amounts of memory, massive amounts of CPU power. No laptop could do it, at least not laptops of today. So I could use my laptop to connect to a network, and that network on the other side connects to a supercomputer, a mainframe computer that's running that program. So even though I don't have the program on my laptop because my laptop can't support it, I don't have enough memory, my CPU isn't fast enough, by connecting to a network, that network allows me to get to a program and run that program on a remote device, so I can benefit from that. I can see where that hurricane's going to go. I can predict that weather pattern. That's another benefit of computer networks. And sharing resources, right? In today's companies, we don't have companies these days where every laptop, every PC has its own dedicated printer connected to the printer port on the back of your laptop. That really wouldn't be financially scalable. So what do we have? Well, we got some printer that's a network printer that's connected to the network. So that's a resource that everybody can share. Everybody can get to that printer. Everybody can access a networked fax machine, or a network copier, or a networked video camera, or something like that, a network security system. So those are all examples of resources that we couldn't have if we didn't have a network. So that completes that first section of this lesson today. So let me go to YouTube Live. And at this point, if you have not yet had an answer to your previous question, you can just copy and paste it back in so I can see it. Or if you have a new question that you've held off on, you can go ahead and put it in there, and I will be more than happy to take a crack at it here. So I'm just going to go from the bottom up. Let's see. Okay, so there's a few questions going back and forth between autonomous systems, about autonomous systems. What is that term? What's the difference between IGPs and BGPs? I see some answers here. That's great. Let me just, in my own perspective, throw that out there. So that's another term that once you get into networking, you'll have to be familiar with. Autonomous system. What is that? An autonomous system, at a very high level defined, is simply a network or a collection of networks that's under one central administrative authority. What does that mean? Well, let's take a real small example. Think of your home network. At your house, you're in charge of how many routers or switches you've got. You're in charge of controlling those routers or switches. You're in charge of your Wi-Fi access points. All the cabling is up to you. So that is an example of a network, a rather small network, but a network that's controlled by one central administrative authority, which is you. You're the administrative authority that's controlling your network. So technically, that little network is an example of an autonomous system. Now, usually when we think of that word autonomous system, though, we think about it in much bigger perspective. For example, think of a network that's owned and managed by a large company that has a campus of like 20 buildings. Well, that is a huge network, but still, they've probably got an IT department that's in charge of that network. They're in charge of figuring out how many routers, how many switches, what's going to go on the network, the security policies of that network. That is another example of an autonomous system. Now, when it comes to routing protocols, and we're going to talk about that in just a second, routing protocols mean when data comes into a router, how does the router figure out where it needs to go? Right? When the data comes into the router might say, well, I've got 5 other interfaces here that could go to this or this or this or this. Which interface do I select to forward this data so it will get to the remote destination? A routing protocol is what assists the router in making that decision. Some routing protocols are optimized, are specifically built to run within an autonomous system. So once again, using that analogy of that company that's got like 20 buildings in their campus, various different ways for payroll to get to marketing, who's in 7 buildings over. There's certain routing protocols called interior gateway protocols, or IGPs, which say we were designed to operate within this autonomous system. We were designed to learn all the routes within our company and figure out the best way to get from any point to any point within our company, within our autonomous system. As opposed to, if you think about, for example, like a service provider, Time Warner Cable, Comcast, Sprint, what's their role? Their role is to connect one company to another company to another company. Their role is to learn about thousands of companies and hundreds of thousands of networks. And so they have to run a different kind of routing protocol that's optimized for that vast scale, optimized so it can manage hundreds of thousands of networks and know the best path through them. So that is called an exterior gateway protocol. So an interior gateway protocol runs within your network. It's optimized to learn stuff within your network. An exterior gateway protocol, which is typically run by internet service providers, is optimized for vastly larger scales, hundreds of thousands of networks. Let me see if there's any other unanswered questions here that I can get into. Anybody else have any other questions here they want to run past me? Looks like you guys are doing a fantastic job at answering each other's questions. Is static routing still in use? Yes, it is. A lot of times static routes are used as like a backup though, where I would run a routing protocol in a router so the router can speak to other routers. The routers can talk to each other and learn where the different routes are. But I might say, well, if this routing protocol fails me, if the routers stop talking to each other, I want to have some other kind of routing in place as a backup. And static routes are typically used for that. ISIS, integrated system to integrated system, that's an example of a routing protocol. And it's definitely useful. There's lots of different routing protocols. ISIS is one of them. Another question, which one, GNS3 or Packet Tracer is better? They have their pros and cons. If you are studying for your CCNA, if that's your objective is to get Cisco's Certified Networking Associate certification, I would probably recommend that you start with Packet Tracer. Number one, main reason is because switching is better in Packet Tracer. At the CCNA level, at the beginning entry level, the things you need to know about switching and how switches work and how you get them to work, you have a lot more you can do in Packet Tracer than you can in GNS3. Now, as you progress beyond the entry-level certifications and you get to the professional and expert-level certifications, that's where GNS3 is better, because from a routing perspective, learning about routers and all the things that routers can do, GNS3 is far superior to Packet Tracer. But when you're first starting out, I would recommend that you use Packet Tracer. Is Python recommended for networking engineers? If you're watching this class because you don't really know anything about computer networking, I would say right now, don't concern yourself with Python. Start learning about computer networks, how networks operate, the various things you can do with a network. Start playing around with them with Cisco stuff. And then once you get more familiarized with networking, once you get like your CCNA under your belt, then maybe you can start looking at Python. Python is a programming or scripting language. For example, if I was a network administrator and I was in control of lots of different routers, lots of different switches, I already know networking really, really well. And I find myself frequently doing the same things over and over and over again, sending the same commands to like 15 or 20 routers, 15 or 20 switches, doing the same things. Well, Python is a scripting language where I could automate that. I could make my job a lot easier by having Python do those repetitive tasks for me. But that's not where you want to start. That's where you already want to know networking pretty well, and then you can go into Python. Now, if you've already been working in networks for a while, then absolutely, Python would definitely be very useful to you. All right, so let's go ahead and go on to the next section. So you guys are doing a pretty good job with answering each other's questions. So I'm going to keep moving on here for the purposes of time. And by the way, I'm in North Carolina right now as we do this on the East Coast of the United States, and it's about 12:50 my time. So we will be taking about a 15-minute break at 1:30. So I'm going to move on ahead so we have a chance to do another 1 or 2 sections before we get to 1:30 today. So let's do that. So the next thing I want to talk about are components of a computer network. I'm just going to define things like what is a server, what is a client, give you some examples of local and remote resources, and some other common networking components that you would find. So let's start out with this term. What are servers and clients, if you're not familiar with that terminology? So a client would be a host, all right? So when we talked about nodes and hosts, a client would be an example of a host that connects to a network. And a client is typically like your laptop, your tablet, your smartphone, your PC, right? These are examples of clients. So a client would typically be accessing information from a server. So a server is also a host. It's also a device that connects to a network. Physically, it might look just like a PC. It might look exactly like one, but what makes it different? Well, a server is a central repository of data. So for example, if we have a whole bunch of people, a whole bunch of clients that need to access the same data, they need to access the same calendar, they need to access the same collection of files, like your payroll files, your human resources files. Maybe engineering has a whole bunch of code that they're all jointly working on. Well, that central place that they would access, where all the files are stored, that would be your server. So for example, most people are familiar with Gmail these days, right? You go to Google and you sign into your mail. Well, your laptop is the client. When you're signing into Gmail, you are accessing the network, and at the other end of that network, maybe hundreds or even thousands of miles away from you, Google, the company, owns a server. They actually own thousands, probably tens of thousands of servers. But when you're going to your Gmail account, all those emails that you're looking at in your account, they're not right there on your laptop. If they were, you wouldn't need to access the network. So those emails you're reading are actually located on a server that also has probably millions of other emails from other customers as well that have also Gmail accounts in addition to you. So as your laptop is the client that's accessing that server. Similar to when you're doing web browsing, right? Like right now, when you went to YouTube, right? Well, YouTube is a company that also has tens or even hundreds of thousands of servers. And those servers have millions of videos on them. So when you pull up a YouTube video, right? Like if you pull up a YouTube video that I've recorded or somebody else at I&E has recorded on YouTube, well, that video is data that's being centrally stored on a device called a server. And you are accessing that server and it's playing that video for you across the network. Now this section here we already talked about, I think, in pretty good detail. Local and remote resources. So some examples of local resources are your own hard disk drive, right? The hard drive in your laptop or your PC. The memory that you've got in your laptop or PC or tablet. Your keyboard you're typing on, your DVD-ROM drive, your optical drive. These are all examples of local resources. You could be completely disconnected from the network, have no network connectivity at all, and still use and make use of all these things. As opposed to network resources or remote resources, as we might call them, like network hard disk drives, right? When you're actually going to Gmail, as an example, you're not only connecting to a server that Google owns, but you're connecting to the hard disk drive on that server where all your emails are stored. So you're accessing a networked hard disk drive. A network printer, networked optical drives that we've talked about. Now, one other thing I want to mention here about local and remote resources. If you're physically looking at something with your eyeballs, for example, you're looking at a laptop, you're looking at a printer, you can't necessarily tell just by looking at something if that device is a local resource or a networked resource. For example, I could have a printer sitting right here next to me. That printer could be connected via a printer cable to the back of my laptop or my PC. In that case, from my laptop's perspective, that's a local resource. I don't need to be on the network to get to that printer. I've got a printer cable connecting directly to it. But that exact same printer could also have a Wi-Fi connection connecting wirelessly to the wireless network. So for other people on the network, that printer is a networked resource. They are getting to it over the network. Now let's also talk about some common networking components now, things that you'd most likely see in a network to get the network to work. This first term here, NIC, stands for a network interface card. This is your connection to the network. If you don't have some kind of NIC in your tablet, your smartphone, your PC, your laptop, you're not connected to the internet, or you're not connected to a network. You need something to interface to the network, and that's what your network interface card is. So some very common network interface cards you might see. So this one right here, on the side of a laptop or a PC, this connects you to a wired network, what we call an Ethernet network, that a physical cable plugs into. For example, this right here. These types of adapters are called RJ45, if you ever see that term, RJ45. Here's another type of network interface card. This kind here would plug into, for example, a server, or maybe a desktop PC, what we call a tower PC that sits on the floor or sits on your desktop that's tall. You'd have this. And notice here on the back, these are network interface cards right here. And you'll see some are called RJ45, some are called RJ11. In this case, in case you're wondering, RJ stands for registered jack. So registered jack 45, registered jack 11. They look very similar to each other. Their size is a little bit different, and the types of physical connectors, the pins they have inside, are a little bit different. RJ11 is typically used to connect to a phone, a regular analog, old style phone. RJ45 connects to a network using the Ethernet protocol. So the NIC cards that you see here in this slide are connecting to the network via what we call Ethernet. So Ethernet is a protocol. The Ethernet protocol dictates, what kind of cable can be used. It dictates what the jack looks like that connects to the network. But there are other types of NICs as well. For example, here we see another type of network interface that connects to a cable network. In this case right here, this is a totally different type of jack, right? This is definitely not RJ45. This type of connector, this type of NIC, is what's called an SMA. Now you would never need to memorize that, but it's called a SMA or sub-miniature version A. But this SMA adapter is used to connect to a different type of cable. This cable here is not Ethernet cable. This is called coaxial. coaxial cable. Also connects to a network, but there's different rules. Ethernet and coaxial use different rules about how to connect to the network, how electricity is used, the rules for when you can talk and when you can't. But this here is another example of a network interface card. And we're not done yet. These are just wired network interface cards. There's also wireless, what I said was Wi-Fi. So in a Wi-Fi NIC gives you your transceiver, right? And what was a transceiver? Transceiver was a transmitter and a receiver. It was a radio capable of doing both, transmitting and receiving. So in a Wi-Fi NIC, you've got your transceiver, which is built in. You typically don't see it. And then the transceiver connects to an antenna, which is capable of transmitting and receiving Wi-Fi signals. Now in this particular case, this network interface card right here has a visible antenna sticking out on the side of it. If you're talking about a tablet, for example, a Nexus 7 or an iPad or something, well, you've got a transceiver inside there, you've got an antenna inside there, but you're not going to see it. You'd have to open up like the guts of that tablet or that smartphone to see where the Wi-Fi antenna is. But to connect to the Wi-Fi network, you need a network interface card. And we also talked about other components such as switches. I mentioned that switches are typically the very first line of defense in a network. In other words, hosts and nodes or hosts connect to switches. That's typically the very first thing that devices connect to. So if I've got a laptop that has a physical cable, an Ethernet cable, that Ethernet cable, the first thing it's going to connect to is a switch. If I have another laptop that has an antenna that's doing Wi-Fi, well, that Wi-Fi is going to be picked up on the other side by an access point that's going to be like on the ceiling or on the wall. That access point in turn is going to have a cable connecting to a switch. And you can see here that switches come in various different form factors. You've got really small switches like Netgear and Linksys switches that only have 4 or maybe 8 ports. You can buy one of these brand new for like $50 or $40. And then for enterprise networks where they need hundreds and hundreds of connectors, you've got the much bigger switches like this right here. This is a Nexus 9000 switch. Whereas this switch right here might start you out at $50. This switch right here starts you out at about $50,000 to buy that, and then it only gets more expensive from that. And then you've got everything in between. And then another very common component of networks I talked about is routers. Also, routers come in various form factors. You've got really small routers that you might be able to buy for a couple of $100s, like a Linksys router or a Netgear router. Or you've got routers that are much bigger, that are much more optimized for enterprise networks like this, right? This right here is an example of a Cisco router. This is a Cisco 2801. Okay. This router here will cost you a couple of $1,000s to buy it, potentially. And then you've got even bigger ones than that. Just depends on what features you want in that router, how complex you need it to be, how much control you need it to have over the network. And then I also mentioned Wi-Fi access points. So I talked about these already. I said you've got your laptop right here. And inside the laptop, it's got a NIC card that you don't see built in. That's doing your radio waves, which then on the other side is connecting to this, or maybe connecting to one of these, most likely placed in the ceiling or connected to the wall. So this is your Wi-Fi access point. And then both of these things would be connected on the back end to a switch via a cable. So those are some very common components in case you were not familiar with those terms: NIC cards, switches, routers, and Wi-Fi access points. So that part was pretty quick. So I'd now like to take it to a Q&A. See if you guys have any questions about common components. Any questions you'd like to run past me here? I see there's some questions here on books that you should get. A lot of people are talking about the Cisco Press books. I would endorse that as well. Wendell Odom is a great author. I love his books. Also, especially if your objective or your goal is to pursue a Cisco certification, like the ICND1 or the ICND2 or a CCNP, I typically tell people at a very minimum start with the Cisco Press books. And the reason for that is because if you're questioning, well, what book can I trust as far as trusting that the book will have the topics I need to learn? It will cover those topics at the level of depth and the level of detail that I need to go for my exam. Well, if it's a Cisco Press book, if it's a book put out by Cisco, that means Cisco has blessed it, they have authorized it, which means that you can feel fairly comfortable knowing that the topics that are in there are the topics you'll need to study. The level of detail that's in there is a level of detail that you'll need to study. Whereas a book that's put out by somebody else that's not necessarily authorized by Cisco Press, well, you're taking a gamble. You don't necessarily know if the topics that are in there are missing something that you need to know for the exam. If the topics that are in there are covering the same level of detail and depth as the exam would expect you to know. So I would definitely go with Cisco Press. Are there any other questions that you would like answered? Okay, so Navneet is asking a good question. Please distinguish between technology and protocol, and what's the difference? Okay. So, for example, I would say that the concept of routing protocols, when I throw that term at you, I use routing protocols in my network. Routing protocols is an example of a technology. A technology says, we have a problem, we have an issue, and we need to develop something that will solve this problem. So for example, when you talk about routing protocols, well, what's the problem? The problem is I have a device right here, and it needs to learn about all the networks are available and how to get to those networks. So if I implement a routing protocol on there, a routing protocol is an example of a technology that answers that problem, that answers how do I learn about the different networks out there. Now, routing protocols is just a generic term, right? So when I talk about a technology does not give you the specifics of how something is done, the rules about how something is accomplished. That is where a protocol comes into play. So for example, a specific routing protocol is EIGRP, Cisco's Enhanced Interior Gateway Routing Protocol. Now, EIGRP is an example of a routing protocol. It falls under the technology of routing, but EIGRP is a specific protocol. EIGRP tells you exactly how the router is going to learn of routes, how the router is going to talk to other routers and tell other routers about what it knows. So routing protocol is the specific details of how something will be done, how it will actually be implemented. A technology doesn't give you the specific details. It tells you, here's the problem, here's sort of a vague, general, ambiguous way that we're going to solve that problem. But if you want to know the details, then you have to find a protocol that falls underneath that technology, and that protocol will give you the details and the rules about how to implement it. Let's see if there's any other questions right here. You want a shirt like mine? Well, I'll tell you what, I don't know if INE necessarily sells these specific shirts, but if you do go to our website right here, if you go to INE.com and you click on the little shopping cart right here, and click on continue browsing, we do have an apparel store. Let's see, where is it here? I think it's down towards the bottom. You know, let's just do this. Let's just search for apparel. There you go. I may have misspelled apparel. Okay, well there you go, just apparel. And then here you got all sorts of shirts. So take your pick as to which ones that you want. Lots and lots of different shirts. As well as coffee cups, mugs, pens, you know, all sorts of good things. Let me see if there's any unanswered questions. So another question here I'm seeing is there a calendar of what sessions that we have and my sessions? Yes, there is. So let me show you how you get to the calendar. So once you create your free members account, you can just go to members, if I could spell, members.ine.com. And once you log in, it will take you to what we call as the dashboard right here. Any course that you see that is in this orange color, this is an online class. And you can click on that. For example, CCIE Routing and Switching. It'll tell you when the class begins, when the class ends. Most of them are not free, right? Most of them require that you have like what's called an all-access pass. And when you purchase an INE all-access pass, you get access, like it says, to all of these online classes. But some of them, like today's, let's see here. This one is actually the wrong color. It should not have been a dark blue. It should have been an orange. But that one, for example, the CCNA kickoff session, which we already had on October 12th, that was one that was free to anyone. And if you click on View Course, a lot of times it will tell you, well, it's been taken down right here. But a lot of times it will tell you who the instructor is for that. But this dashboard here is where you would look to see what courses are being offered. Let's see if there's any other questions right here. Juan's asking a good question. In your experience, how many switches, layer 2 and layer 3, and routers are most likely to find in medium to large size enterprise networks? Dozens, sometimes hundreds. In a medium size enterprise network, well, it depends on what you consider to be medium size. You know, for a very short amount of time after I left Cisco, I worked at a company that had, I think they had 900 employees. So a lot of people consider that a medium-sized company. That company probably had a couple dozen switches and maybe, I think they had less than 10 routers. So that was medium size. A few dozen switches and 10 or less routers. A large company, you know, when I worked at Cisco, Cisco out here in RTP has about roughly 15 buildings. And each one of those buildings is anywhere from 3 to 5 stories tall. So you figure that network, that large network, literally probably has hundreds of switches. And it would be very reasonable to say in those 15 buildings, probably each one of those buildings has a minimum of a dozen routers in it. So probably hundreds of routers as well. Someone's asking, is it worth it to quit your job for the CCIE lab preparation? I don't know. Yeah, a good answer. If you can afford to quit your job, go ahead. I would not advise that. You know, if you are able to actually get a CCIE, and to get a CCIE, you have to pass 2 exams. You have to pass a written exam, And then once you've passed the written exam, you have to pass what's called the lab exam. The lab exam is actually where you go somewhere and you create, they will tell you, create this lab, make it do this, make it do this. And then they'll break the lab and they'll say, fix it. Very intensive. Now, if you can get a CCIE, I wouldn't necessarily say you're guaranteed a job. Getting hired is more than a certification, right? You can have all the certifications in the world, but if you go into a job interview and they think you're odd, you can't talk, you stumble over your words, you come across as being narcissistic, you come across as being someone that they just don't want to work with. Well, you could have 5 CCI certifications, but if you leave that company and say, man, that person was weird, no one here is going to want to work with that guy. Doesn't matter how many certifications you have. If you're not able to ask their questions, right? And a lot of times in today's networks, today's job opportunities, they want you to have more than just networking experience. They want you to have certifications on virtualization, like with VMware. They want you to have experience with servers. They want you to be able to configure Active Directory and all sorts of other stuff. So just having a CCIE certification by itself is not going to guarantee you get a job. It'll get you in the door, you'll probably get the interviews, and it'll get you very close, but to give up a job that's paying for your bills, that's paying for your lifestyle to just certify for the CCIE, I would not recommend that as a good approach. Let me just scroll up here and see if there's anything else. All right, I don't see any other unanswered questions I can get to real quick. So let's just go into one more topic here. And then we will break. Actually, you know what? This next topic is probably going to take me a good 20 or 30 minutes to cover. The next topic we're going to look at is technologies that comprise a network. And in this particular topic is where I'm going to do some whiteboarding to describe what is routing, what is switching, what is data center, collaboration, security. And I don't think we can get that in the next 10 minutes. So why don't we take our break now? I did see some of you guys saying, coffee, break. I agree with you. I think now is a great time to have a break. So we're going to take a 15-minute break. And then after 15 minutes is over, we'll come back and we'll jump back into this again. So I will see you guys in 15 minutes. Hello, my name is Keith Bogart, and I'm one of the instructors here at I&E. And if you're watching this video, it's most likely because you're considering attending our CCNA Routing and Switching Bootcamp. But you may have some questions about it, and I'm here to hopefully answer those questions. So let's get started. Probably one of the most important questions is, why should you attend I&E's CCNA Routing and Switching Bootcamp? One of the best reasons I can give you is dedicated learning. When you're doing your own self-study, there's all kinds of things that can distract you, as you well know. But when you're sitting in our classroom, in our boot camp, you'll have 5 to 7 days of dedicated learning for these routing and switching technologies. Nothing will be available to distract you. You'll be heads down in learning these protocols. So what else is a benefit? You'll also get instant answers to your questions. Once again, when you're doing your self-study and you get confused or stuck, where do you go to get an answer to your question? Most likely you're turning to some kind of online community or forum where you might have to wait hours or days to get answers to your questions. And hopefully those answers are clear and not ambiguous. When you're sitting in one of our boot camps, you have a knowledgeable instructor dedicated to you right there. You can ask any question at any time. As a matter of fact, the instructor will encourage that to make sure that you're getting the most out of your boot camp experience. Another benefit of attending our boot camps is instructor-assisted labs. You know that as you're pursuing your CCNA certification, you need to have hands-on lab time. There's no better way to learn the Cisco iOS command line and memorize the commands and what you should expect via various show and debugging output. But if you're doing labs on your own, where do you start? What feature is important? What features should you ignore? When you're in one of our boot camps, all those questions are answered for you. The boot camp labs are structured to highlight the most relevant features and protocols that you're most likely to see when achieving your CCNA certification exam. Also, you'll have the instructor right there, so if you get stuck during a lab, that instructor can help walk you through it and answer any questions that you might have. And of course, it goes without saying that sitting in a boot camp experience, you'll have lots of interactivity. Not only will you be able to engage with the instructor, you'll have other students around you who have varying degrees of networking experience, who you can bounce ideas off of, and who can give you some ideas as to how this stuff is used in the real world in their own networks. So what can you expect by attending one of our boot camps? Well, certainly you can expect long days. There is a reason why we call these boot camps. The Cisco CCNA covers a lot of material, and so in order to learn this stuff, we're going to have long, grueling days, so be prepared for that. Be prepared to be dedicated to this experience, should you hopefully choose to go. You'll have lectures and lab demonstrations. The instructor's not just going to sit up there for 8 or 10 hours hitting you with one PowerPoint after the other. In order to reinforce the material, you're going to have frequent whiteboarding, frequent verbal explanations of how this stuff is used in the real world, and lab demonstrations, so you can actually see how to configure, monitor, and troubleshoot this on real equipment. You'll also have equipment of your own, so if you choose to do so, you can follow along with the instructor's lab demonstrations. And you'll have do-it-yourself labs. Now, this is the type of lab or term I've coined that means once the instructor has taught you a particular topic, that person might put some lab objectives up on a slide or bullet point. Real high-level objectives. Configure this protocol. Make it talk this way with this device. And the idea is you have a certain amount of time to try to make it work on your own, to see if you've actually learned the material and can incorporate it into your own lab. And then, of course, at the end of the time, the instructor will go through that lab and show you how to complete it. You can also expect verbal quizzing during the lab. This is one of many tools the instructor has to do testing for understanding. The instructor will frequently ask individuals within the class questions pertaining to what has just been taught, or maybe things that were taught hours or days before, just to make sure that you're actually retaining the knowledge. So what are some of our prerequisites to attend a CCNA boot camp? This boot camp is not designed for someone who has no networking experience at all. We do expect that you will have done some self-study prior to attending this boot camp to get the most out of this experience. The ideal candidate, before attending our CCNA Routing and Switching boot camp, will have spent a minimum of 2 to 3 months in their own self-studies. Now, in order to help guide you further, if you go to streaming.ine.com, our website, and from there, click on Cisco, CCENT, you'll see that the very first topic is called Operation of IP Data Networks. That consists of about 3 hours of videos that fall under that general umbrella. So ideally, you would watch those 3 hours before attending our boot camp, or get a similar level of knowledge via your own self-studies of reading, white papers, or wherever you go to do your self-studies. So with that, hopefully I've answered your questions, I've whetted your appetite to attend our boot camp, and I will see you there.
You know, I think that when I first started that there was, you know, I had a perception that I knew a lot about the core protocols. And now, you know, I realized I didn't when I first started. And this has really filled in those gaps. Just getting in there, labbing the stuff, seeing the problems, correcting the problems.
I've never seen anything out there like this. And I've been to multiple Cisco courses for my CCNP, CCNA. But this, you actually get to see the technology work. So it kind of helps stick it in your brain.
Our sessions are very interactive, always available to answer any questions during the session or offline.
He gives you the right mentality you need to approach any problem or troubleshoot or, you know, answer a question on a test.
It's helped me a lot, you know, even stuff that's not even for the CCIE, you know. I had the all access pass, just the knowledge that you get from them, you know, not only like, you know, this is how you configure it, but they actually show you in the video, this is how it works. And that's what you need. You can't just read a document and be like, well, this is the configuration. So hopefully it works, because sometimes it doesn't work.
I wish that I'd start off with material just like this, because I would have understood right off the bat what the theory is and what it's actually doing in the command line.
It's definitely more advanced. I think it's explained in a better way, better analogies. I think it's tougher, which is good. You know, I took one that was earlier and it was easier, you know what I mean? So it gave me this false confidence. And so now getting into this stuff and you see like, wow, this is a little bit more advanced. So, you know, I want to do some more of this stuff, and now I'm starting to feel way more comfortable.
A few of the weak spots that I had, I'm able to get over those things and understand those things better.
It's easy to study for a test and just study exactly what you need to know, but in this class we've gone kind of above and beyond, and he showed us things that can actually apply in real world and some things that may not be applicable to the exam, but are good things to know, especially when troubleshooting. And
I definitely recommend it. I've been recommending it. Just using the materials, now going to the camp, I'd recommend it all day long. It's a completely different learning experience.
Welcome back, everybody. Hope you had a good break. Before I start again, I'd like to just point out this is actually the promo that INE is running right now that I tried to get to at the beginning of the course, but I just want to bring it up right now as well. So you'll notice that for the month of October, INE is doing this gaming bundle for all of our customers. So as long as you have an INE members account, you are automatically entered into this drawing here for this bundle, consisting of a Razer gaming laptop as well as headphones and a carrying case. And of course, if you actually purchase anything from us, you get even more entries from this. So just wanted to show you that that's something we're doing for this month of October, about halfway through it right now. All right, so let's go into this next section here about technologies that comprise a network. I'm primarily going to be doing this on the whiteboard. So let's first of all talk about routing and switching. And what is that? So we talked briefly about switching already, so let's just go into a little bit more detail about that. So I mentioned that switching was originally developed so that we could have multiple devices connected to a network, and instead of all of those devices being physically connected to one cable that they had to share, instead each device would have its own special cable, its own unique cable that was connected into a central device called a switch. So technically, to do switching, there's really not much human involvement. You just have to purchase the switch, plug it into a power source like the wall, plug your Ethernet cables into your laptops and PCs, turn everything on, and voila, now I can do switching. In other words, now the switch, without any intervention from you, can take in data from two devices, and if the data comes in at the exact same time, that data is stored into some memory so it doesn't run into each other. And then the switch will decide, okay, the data that came in here on port number 3, I'm going to forward it out port number 1. And the data that came in here on port number 2, I'm going to forward that out on port number 1. So we'll do all that in the background. So where's the human intervention involved here? Where would we need to get involved with switching? Well, from the perspective of things like security. For example, let's say that what I wanted to do was I had a couple of devices right here that were in payroll, and I had a couple more devices right here. Forgive my sloppy drawing, and those were in marketing. And they were all connected to the same switch. And my objective was that I did not want the marketing devices having access to the payroll devices. That would require some intervention on my part. I would have to configure something, for example, like virtual local area networks, VLANs, to separate them out. And that's not done by default. That's something I would have to do, to configure these ports on the left to be in a completely separate group than the ports on the right. There's lots of other security features you can configure on the switches to determine what data is allowed through and what data is dropped by the switch. Certainly if we start getting a larger switch network, where maybe I'm connecting one switch to another switch, switch 1 to switch 2. Well, I can just connect a cable between those two switches, but there's a lot of things with human intervention with Cisco commands or other commands that I could use to modify the characteristics of how these two switches will talk to each other. I can connect more than one cable, and using certain features like ether channel and port channeling and things like that, I could dictate how these switches will talk across those cables, how the information will be transmitted to and from across those cables. All that stuff requires human intervention and commands. If I start connecting, several switches together, like maybe 3 switches or more, Well, now there's things, other protocols and features, for example, spanning tree, which I'm going to start thinking about. Spanning tree is designed to make sure that if data enters my switch network, that it doesn't just go around and around and around in a loop and never stopping. Spanning tree fixes that. So as my switched network gets bigger and bigger and bigger, there's going to be more human involvement needed on my part as a network administrator to start configuring more features for security reasons, more features to dictate how data is going to flow through the switch network, where it's going to go in the switch network. And so from a switching perspective, so if you specialize in the world of switching, this is the type of thing you'd be doing. You'd be dealing with these switches and implementing and monitoring and controlling and troubleshooting these types of features. So that's switching. So what about routing? What's routing? So imagine that you've got one section of the network over here, which is, let's just say this is payroll. And there's some switches in here. We don't know how many. I'll just draw a bunch of switches. And there's another section of the network over here, which is engineering. And they've got their own switches and servers and laptops. Another section of the network over here, which is marketing. And just some other portions of our network. You know, you can figure out what they are, come up with your own names. Now, we want to connect all these different networks together, but we want to maintain security. We want to maintain control over what data is allowed to go from one section of the network to the other. So to do that, we buy some routers. Let's say we have a router here, another router here, another router here. So these circles are going to represent my routers. And these lines are going to represent my physical cables connecting one router to another. So I'm just randomly drawing something right here. So you can see there's a lot of redundancy. Now, what do I mean by redundancy? That means to get from one point to another point in the network, there's a lot of different paths we could take. That's what we mean. The more redundancy a network has, the more options there are, the more paths there are that could be taken to get from one point to another. There's not just one way. So routing is setting these routers up and configuring them so they know when something comes in. For example, let's say here comes in some data, and this data is destined for marketing. That's where the data needs to go to. Well, once it hits this router, it could go in a variety of different directions. It could go here, over, and down. It could go here, over, and down. It could go across, a variety of things. Routing is how do we get these routers to know where the paths are? For example, this router right here that I've drawn, I'll go ahead and fill him in. Just by plugging in his cables and turning on the power switch, he's going to know the networks that he's physically connected to. For example, whatever this network is, this network, and this network. He'll know about those because he's physically connected to those. But the networks that he's not touching, like these cables over here, by default, he's not going to be aware of those. So when you specialize in routing, you're specializing in how do I get this router to know about other networks that he's not physically touching, all the different paths to reach those networks, which path is the best network, which path is the best path to reach that network. So at a very basic level, that's what routing is. So if you specialize in that, you'll be dealing with that technology. So technically, just to know how to get data from point A to point B, you really need to know a combination of switching and routing. And that's what the CCNA routing and switching exam really focuses on. Now, it also focuses on other stuff like wide area networks and security and stuff, but there's a reason why they call it CCNA routing and switching, because the primary emphasis is by the time you've gotten your CCNA, you know how to implement switches in a network. You know how to implement routers in a network. And you can get a network up to a point where any device in one section can get its data to any other device in another section of the network. So we don't really have to know anything about security or some of the other fancier terms like quality of service or a data center to be able to get just basic network functionality up with routing and switching. Now let's say that you've been doing this for a while. You know, you're pretty good on switches. You know what the various features are on the switches. You're pretty good on routers. You know, you can get the network to where the data can get from point A to point B. Now you want to go on to the next level. You want to take your knowledge up a notch. What other technologies are there available to you in addition to routing and switching? Well, the next thing I'm going to talk about is data center. So let's talk about that for a moment. Okay, so we know that we've got our various different parts of the network. This is maybe payroll, you know, this is marketing, this is engineering, whatever they are. And then somewhere in our network, we have a highly secure room, right? It's got a badge reader on it. It's got, you know, poisonous gas in case somebody gets in there who's not supposed to be there. It's got, you know, very violent dogs that will rip your arms off. And in that special section of the room, of the network, that's where our data center is. And in case you didn't hear me explain that earlier, in case you just joined us, the data center is a central location in your network, very secure, where you're storing all of your servers that have all of your mission critical data. Also, in a lot of today's data centers, you know, with the evolution of data centers, it used to be that, okay, we start out with all of our information locally on my laptop, locally on my PC. And then people said, not good. If that laptop or PC crashes and dies, all the data goes with it. So they said, let's move our data off to another thing called a server. And on the server's hard drive will be all that data. And we'll also back it up to another server. And then all the laptops and PCs can get to that. Well, then people started realizing, well, servers only have a certain amount of disk space. Their hard drive is bigger than the hard drive in my laptop, bigger than the hard drive in my PC. But if I'm talking about a server, this can be storing all the engineering data, all the payroll data from my company that's got, you know, 20,000 employees. That hard drive on that server is probably not going to be big enough to store all that stuff. So they said, why don't we do this? Why don't we create special devices which are just a box for a massive hard drive? They have, you know, a hard drive that's bigger than any server would actually store locally. And so we call that a disk array, or sometimes called a storage area network. So I'll just say this is a disk array right here. A RAID array. And somebody, now I'm not a storage area networking guy at all, but I think somebody on YouTube Live, you can correct me if I'm wrong, but I think in this case RAID stands for, it's either rapid or redundant array of inexpensive disks. So like, you know, in your laptop, you've got a hard disk. And if you actually open up the guts of your laptop, you would see there's a disk in there, like a CD-ROM, basically like a CD that spins, and that hard disk is what contains all of your data. Well, RAID array is a box that's got multiple disks in it, you know, so an array of these disks spinning. And so this RAID drive can have tons of data stored on it. So in our data center, we've got all sorts of servers, we've got some external disks, all sorts of stuff. So how does this have to do with networking? Well, all this stuff has to be connected to a network. And chances are the way you connect this to a network is going to be a little bit different than the way you connect your laptops and PCs to a network. For example, the network connectivity here has to be much more, what's the word I'm looking for? The uptime, the resiliency of it has to be greater. In other words, if the connection to my laptop goes down for 3 or 4 seconds, that's going to be kind of irritating to me, but it's not going to kill me, right? It's not going to be the end of all things. But if I have this server that thousands of people in my company are accessing, maybe it's got mission critical data, if that network connection goes down for 3 or 4 seconds, that could translate to thousands, tens of thousands, or hundreds of thousands of dollars of lost productivity, of lost revenue. So the network connections to these guys is different because it has to be much more reliable. That's the word I was looking for. The reliability has to be greater. Also, a lot of times there's a lot more redundancy. For example, your laptop probably only has one network connection. Maybe right now you're connected via Wi-Fi, or you're connected via a single Ethernet cable. If that network connection goes down, what happens? You're done. You've lost your network connectivity. We don't want that happening in these guys. So a lot of times these devices will have more than one network connection for redundancy. So if one goes down, you can still get to that device. The speed of these connections. You know, most of the network connections we have these days to our laptops and to our PCs are either Wi-Fi or maybe a hardwired Ethernet connection. And for our purposes, as the average user of that device, the speed of that network is perfectly fine. You don't usually notice anything. But you're the only person on that device. These network connections here are sending and receiving data from potentially thousands or tens or hundreds of thousands of people. So the speed, the amount of data that these connections have to transfer back and forth is a magnitude much, much greater than what connects to your laptop or PC. So I'm trying to emphasize here is that yes, these things connect to a network, but the type of network, the protocols in use, the technologies in use here are different than the protocols and technologies that are used to connect your hosts, like your laptops and your PCs and your IP phones, to a network. So the person who specializes in data center networking will know all this stuff. They'll know the special types of switches that are optimized for this type of speed, this type of redundancy, this type of resiliency. And that's what data center networking is all about. How do we create a network that's optimized for this very important part of our network? That's data center networking. Now, another term you might see in networking is the term collaboration. And all of this actually goes along with Cisco's certification exams. So Cisco certifications, there's a CCNA, and the CCNA is sort of like the entry level certification, and then it goes all the way up to the expert level certifications. And all of these certifications have specialties in, for example, CCNA routing and switching, CCNA data center. And now we're going to talk about CCNA collaboration. And you can go all the way up to the expert level of all of these things. What is collaboration? All right, let me go back to the white screen and talk a little bit about that. Oops, what happened there? Okay, so once again, I've got my typical data network. These are the laptops of my various users. And they are connected into my switch. And, you know, here's my data center down here in this cloud, which also eventually connects out to this switch as well, so they can get back and forth. Now, remember how I mentioned earlier, I said, you know, back in the early days, most companies had two completely separate networks. They had one network for their data, and they had another network for their voice. Their voice network could just be, you know, a couple of phones connected to Pacific Bell or AT&T or, you know, Bell South or whatever. Or you could have, if your network is a little bit bigger, if you had a whole bunch of employees, maybe you had their phones connected to your own telephone switch, was called a private branch exchange, a PBX. So PBX is like a little mini telephone switch, sort of the same type of switch that the telephone companies use when you connect to them. But that was a completely separate network. The wires and everything were for voice, and then you had a completely different network over here for data. And then I mentioned some people had the bright idea. They said, hey, instead of paying hundreds of dollars a month for this voice network, why don't I get rid of that expense and take my voice and put it onto my data network? So collaboration is about How do you do that? How do you get these special phones, which are called IP phones, because they're using the Internet Protocol, which is the same protocol that your laptop uses, and how do we connect those to the network? They're going to have to talk to a special server that allocates like telephone numbers to them and allows them to talk to each other. So how do we incorporate voice onto this data network? How do we make sure that the voice is secure, that the voice traffic doesn't impact the data traffic, or vice versa, that we make sure the data traffic doesn't impact negatively the voice traffic? How do we do that? Well, collaboration teaches you the tools and features and protocols for that type of thing. Not only that, but then some people said, hey, video could be a real useful thing in networking. It'd be kind of nice if, every single week we've got these meetings over in the cafeteria where all the people have to leave their cube, go to the cafeteria and have a meeting. Wouldn't it be kind of nice if we could just have a video camera of the speaker and have that video put onto the network, and people could just stay in their cubes, they could stay in their offices and watch it remotely? What about telecommuting, right? How do we incorporate video onto the network? I do not know how to draw a video camera, so I'll just put something like this here. And here's our CEO who's doing his bonus speech about the great big bonus he just got and how nobody else is going to get one. And then, that's connected back to some sort of server, which is converting all this stuff into IP. And then that is connected to our network. So here we have video. This is also part of collaboration. So if you specialize in collaboration, this is the kind of stuff you're doing. You're learning how to incorporate voice and video and multimedia onto the network that previously was just doing data, and using the various security tools to optimize that stuff and make that all happen. So that's what collaboration is all about. And then the last one I want to talk about is security. So I'm not going to whiteboard this. Let's just talk about this verbally. So I think you start to get the idea of, I've been emphasizing security a lot because a network is a shared resource and you don't have control over the human beings who are accessing this network. You're hoping that they have good and pure and honorable intentions, but we don't know, right? So we want to protect our network. We want to protect the laptops that are connected to the network from getting viruses and worms and Trojan horses and all sorts of other things. We want to protect in our data center those very critical RAID arrays and those servers that have our mission critical data. We don't want people hacking into those devices and erasing the data or replacing it with something wrong or cutting off service so those devices can't be accessed at all. So if you specialize in network security, that's the type of thing you're specializing in. You're specializing in what we call network hardening. How do I harden my network? Hardening means how do I put like a protective shell around the network so that intruders, people with evil intent, can't work their nefarious plots within my network. There's all sorts of ways to do it. How do I protect my network from the outside, right? How do I protect someone from the internet? I want people from the internet to get to my web server, but I don't want them to crash my web server. I don't want them to get to the interior of my network and get to the special file server over here. How do I do that? What types of features and protocols and technologies can I implement on my routers and switches and other devices? There are other devices, network devices, that are specially optimized for security, like firewalls. A lot of times you'll hear this term Cisco ASA, which stands for the Adaptive Security Appliance. That is a special device optimized for security. Its main role is to protect your network so that the good stuff can get in and out, but the bad stuff is not allowed in. And there's other devices as well. There's things called intrusion detection services, IDS boxes, intrusion prevention services. The world of security is huge. And so if you specialize in network security, that's where you're going with that. Now, like I said, the foundation of all of this is routing and switching. I'll tell you right now, if you try to go let's say that right now your job role is in payroll, all right? You don't know, the only thing you know about a computer is how to get on your computer, how to log in, and how to bring up the internet. You don't know anything about networking. This stuff I've been teaching you today is brand new. Networking components, routers and switches, all new. You will not want to jump immediately into network security or data center or collaboration. As cool and fascinating as that stuff might sound, you need a foundational background in routing and switching first. If you don't understand how the network just simply gets data from point A to point B with routing and switching, none of this other stuff is going to help you. It's just going to confuse you. So you're definitely going to want to spend some time doing routing and switching first. And then if you want to branch off into these specialties, you can. Also, whether or not you're actually going to get a job in these specialties, a lot of that depends on the type of network you work on. In a lot of smaller, small to mid-sized networks, the person working on the network is supposed to know a little bit about all this stuff. But the larger networks, for example, if you work in an enterprise that has like a campus of 30 buildings and an IT staff of hundreds of engineers, very good chance you'll have the opportunity to specialize in security or collaboration or data center. But a lot of networks these days, you have to wear multiple hats. You not only have to know routing and switching, but you have to know a little bit about all of this stuff because they just don't have the financial resources to hire engineers that are specialized in each and every one of these things. All right, so that brings us to our next Q&A section. So let me go to YouTube here and see if there's any unanswered questions I could help you with. Yeah, so there was a good question here. Can I start a security career with CCNA security? Yeah, you can absolutely start it. Most likely, if you are, let's say that you get your CCNA routing and switching because you don't want to pass that, and then you get your CCNA security. Most likely, if you just have those two things, you're not going to be sufficiently prepared to interview for a job that's a security specialist. Like if you're going to, for example, Microsoft, and you're going to their main campus in Seattle or wherever they happen to be, and they're looking for a network security engineer, that will not have enough, you won't have enough experience and knowledge to apply for that type of a job. However, if you get those two types of certifications, you're definitely ready to work as a network admin in the main routing and switching and start dealing with security. Start dealing a little bit with it as sort of like an offshoot of your job, but not as the main job itself. Somebody was asking, wasn't there also a service provider branch? Yes, there is service provider. So service provider is dealing with, for example, I mentioned earlier about BGP. I said exterior gateway protocols. I said some protocols are optimized for learning massive quantities of routes, hundreds of thousands of routes. So if you want to specialize in that type of thing, how do I work at a service provider where I have to know things like routing for massive scale of routes? I have to learn how to really control my routing protocol. So I have a lot of ways of manipulating how it selects the best route, how it filters out routes that it doesn't need, how it optimizes routing on a massive, large scale. The service provider track would be for that. Also for things like quality of service, right? If you think of your service provider like Time Warner Cable, Spectrum, Charter, whatever they are, they've got massive quantity of data running through their network. So one of the things is at the top of their mind is if any part of our network starts getting congested meaning there's so much data being driven to this part of the network, this network can't handle it. This network can't handle the quantity of data that's trying to go through it. How are we going to deal with that? And QoS is answering that question. The quality of service says, okay, if there's a point in my network that's congested, I want to be able to manipulate what's going to happen at that point. I want to make sure that if something's going to be dropped because there's no more room for it, I can control what's dropped. I can control how the data is prioritized and sent across my network. That's another thing that service providers have to be familiar with and that the service provider track highly focuses on. That's a very good question, Prince. How is automation going to affect jobs in network security? That is a great question. I don't have experience in that, but if any of you other guys want to get. Well, that's going to be difficult. You're in a difficult spot because you're right. That you could be an engineer, and because of your experience, you could very well have practical experience and knowledge of stuff that's on the CCNA and CCNP. But here's the thing, if an employer is specifically saying in their job description that it's a requirement for CCNA or CCNP, they're not even going to look at your resume. You could tell them that you've got all sorts of experience, but chances are you can't prove it. That's the problem. You know what you know, but they don't know what you know. And by having the actual certification, that's a way of proving to them that you have a certain knowledge, a certain skill set. So you will just basically have to, a couple things you could do. I don't know if anyone's ever tried this before, but maybe you could try creating some YouTube videos. Create a YouTube video on explaining BGP and how BGP works. Create a YouTube video on switching and VLANs and some of the more complex topics you'd find in the CCNA and CCNP. And then when you submit your resume, have links to those videos in there. So in your resume, you'd have something you could show them to demonstrate that you know this stuff. But that's the whole purpose of getting a certification in the first place, is to have some sort of verifiable proof that you have network knowledge. All right, so let's go on to this next section here, which I have titled Computer Networking Job Roles. And here I'm primarily going to be talking about the terms of network architect, network engineer, network administrator, and sort of defining what they are and what makes them different from each other. So before we get into that, when you are working with computer networks, you're going to be doing several different things. So these jobs that you could get fall into different categories. For example, network analysis. Network analysis means you are looking at an existing network and you're gathering statistics and facts and figures from that network with the intention of, is this network operating at the best capacity it could? Are there any potential problems which look like they could be around the corner, which we could mitigate with new features or protocols or hardware? Is there a way I could optimize this network by changing it in some way? So network analysis is someone who's really good at looking at an existing network and saying, is this as good as it could get? Network design. So network design first requires network analysis. So you have to have the skills of network analysis to see, okay, what is this network? What types of data, voice and video is on the network? What's the percentage of each one? Is it during certain times of day? Are there any points of congestion? If there are, what's causing the congestion? Where is the congestion happening? You have to know the network inside, and any routers and switches do I need? What types of security mechanisms are they going to need in their network? So network analysis and network design are probably the top level as far as how much education and experience you need to have. You need to have been working in networking for a long time, have a lot of experience with a lot of different things to get into the role of network analysis and network design. And then there's network implementation, sometimes called racking and stacking, right? Network implementation involves things like taking brand new devices out of the box, putting them into the rack, screwing them in, plugging them in, turning them on. Cabling, swapping out cables, putting in new cables. Initial configuration, taking a device, turning it on, and then configuring it to do these additional things of security and routing and switching that aren't done by default. That's network implementation, making the network work. Network troubleshooting, I think that's pretty clear. You know, identifying problems in the network and identifying the root cause of the problem and fixing it, and then hopefully changing the network so that root cause doesn't happen again. So that's network troubleshooting. And then there's network monitoring. Network monitoring is you've got an existing network and you're constantly looking at it. You're looking at this section over here saying, okay, is it healthy? Have any devices crashed? Do any devices look like they're about to crash because I'm looking at their memory and, oh my gosh, this device right here, his memory is like consistently 90% used. There's very little memory left. This device over here, his CPU, his processor is consistently running between 90 and 95%. I need to upgrade that. This link right here, I'm getting a lot of statistics as dropping consistently frames and packets between 2 p.m. and 5 p.m. every single day. So network monitoring is looking at the existing network with the eye of, is it okay? Is it healthy? Is there anything that's a current problem or could potentially be a problem? So network analysis and network monitoring go hand in hand. I separate them out here because from my viewpoint, network analysis is you're looking at the network with a specific objective of what changes can I make to it? Is there something I could do to this network to make it better? Network monitoring is really looking at the network from the standpoint of, is it healthy? Is it doing what it's supposed to be doing? Not necessarily I want to make it better, I just want to make sure it's operating the way it's supposed to be operating. That's network monitoring. So computer networking job roles will require you to perform one or more of these duties. Most likely, when you first get started in the networking industry, the tasks that you will be doing is probably network implementation and maybe a little bit of troubleshooting. So that's usually where you start, is with network implementation, and then as you do that more and more, you get into network troubleshooting. And then once you have some experience with that, you can branch off. Usually people then start doing network monitoring, and then this comes at the end when you have many years of experience. All right, so let's talk about job roles that incorporate some of these things or all of these things. So these are the roles I'm going to talk about: the network architect, the network engineer, administrator, and technical support and help desk. So let's start at the top. The person who has the most experience commands the greatest paycheck, and that would be your network engineers and network architects. All right, so network architects and engineers, like it says, are generally hired to work on larger networks. So these are companies that have really big networks, that the network, because the network is really increasing productivity in the employees, it's really critical to data. This company can afford to spend a lot of money to bring someone in to make it better, to architect it into something even better than it is. So network architects and engineers do network design and conception. Prototype testing. So the network architect engineer might say, okay, maybe a network architect came in and was contracted for like 6 months, and when they left, nothing actually changed, but when they left, they created like 300 pages of documents that said, okay, here's the features I think you need, here's how you should configure those features, here's the parts of the network where they need to be implemented, here's the types of routers and switches you need to swap out and replace with this other model. So they left with a thick series of recommendations. Now the network engineer comes in. Now the network engineer says, okay, before I actually implement those, I want to make sure it works. I want to do prototype testing. So maybe I will set aside a little lab of like 20 routers and I'll try out some of those features that were recommended. Do they have any bugs? Do I know how to configure them? Are they actually doing what the architect said they're supposed to do? Maybe I'll buy one of those new routers and make sure that it really will work the way I think. I know all the intricacies of it before I buy 50 of those routers and implement them into my network. So the network engineer will typically do the prototype testing. And engineers, well, especially architects, network architects are frequently hired as consultants. So they're not full-time permanent employees. They come in for to accomplish a task, to accomplish a project. They are very highly paid for that. But if having job security is what you want, if you're having a consistent paycheck with bonuses and health benefits and PTO is what's really critical to you, the network architect might not be your job because they don't get that, right? They go in, they get a really big fat paycheck for doing a project for 3 to 6 months, and then they leave. And then hopefully they'll get another job. So an architect really specializes in the design of networks, whereas the engineer really focuses on implementation of the network. So for example, in this scenario right here, if we take a look, so I'm going to be frequently referring back to this topology and saying, okay, how would a network architect work on this topology? What would a network administrator do with this topology? So the question is, what value does a network architect bring to this topology? Well, the network architect would look at this and find answers to questions like this. Questions like, how many users do we have right now on this network? Where are they located? You, Mr. or Mrs. Customer, how do you see yourself scaling? How do you see yourself hiring more departments and more users in the future? Where do you see your network growing? What types of information does the network carry now, and what types of information do you think it will carry in the future? What type of SLAs will you need? If you're not familiar with that acronym, that stands for Service Level Agreement. In other words, maybe the customer says, well, you know, here in my data center, I need to make sure that 99.9999% of the time that is up and reliable. Whereas here, where my users are, that's okay if that's just 90% up and available. Well, the network architect will need to know that because that will dictate what specific hardware, software, and features need to be implemented to give these types of reliability ratings. They'll also ask you, how do you need to separate or group your traffic for security or QoS reasons? They'll even ask things that normally you wouldn't necessarily think of as being networking related, like what materials are your walls and ceilings made out of? For example, if you're dealing with Wi-Fi, like down here, that's a very critical question. If there's a bunch of metal filing cabinets here between this user and their Wi-Fi access point, that could be an issue. Wi-Fi does not like metal, right? If there's a bunch of concrete, Wi-Fi just hates concrete. It doesn't go very well through concrete or brick walls. So knowing, how the actual building materials are implemented in your office will also affect that, right? If you're running cabling, the network architect needs to know, okay, if I'm designing a cabling solution, my cabling specification, my cabling recommendation is going to be very different if people are using drywall, which I can simply just punch a hole through, versus cinder blocks, which is going to be a lot harder. That's also going to affect how the network architect brings his or her recommendations to the table. Now, what about the network engineer? If the network engineer is looking at the same topology, how are they viewing it? What are they thinking about? Well, several things. I already mentioned the network engineer is going to perform proof of concept testing with simulated environments or smaller scale mock-ups. They're going to say, okay, well, let me test out this routing protocol before I roll it out to all of my routers. Let me test out this security feature before I roll it out to all of my firewalls and switches. They're going to be doing proof of testing. They will decide on specific equipment models or software selections. Sometimes the network architect will say, okay, based on what you told me, you're going to need 20 access points to have the coverage over here for Wi-Fi that you need. But the network architect will say, I'm going to leave it up to you to decide what model of access point. Or maybe that'll be part of their contract. They'll say, okay, if you're willing to pay me $100,000, I'll come up with a design about where you need routers and switches, where you need your cables, what types of features you need. But if you actually want me to specify, give recommendations on specific models of routers and switches, models of access points, specific types of cables and where you would buy them, well, that's going to cost you an additional $20,000 onto the project. So maybe the company might say, no, you give us the design advice, we'll use our network engineer to do that other stuff. So a lot of times that's the job of the network engineer to figure out what specific makes and models of hardware will be implemented to fulfill the design requirements. Things like purchasing subnets, right? You're going to learn about the internet protocol and IP addressing. Well, the job of actually purchasing IP subnets from regional internet registries, that's something that the network engineer is going to do. Making decisions regarding design and implementations of smaller scale change requests. For example, maybe there's a need to upgrade a link or purchase different blades for a modular switch. Or maybe there's a need for additional redundancy that just happens on a day-to-day or a monthly basis. Well, you're not going to bring in a network architect and pay them $50,000 just to decide that you need to purchase some additional cables or you need to purchase some additional modules for a router or switch. That's overkill. But your network engineer working in your company, that's something they should be able to do. They should be able to figure out, oh, okay, well there's this, I'm study up on Cisco every day, I read their newsletters and their papers, and oh, I just read up on this new network module. Yeah, I think that what that thing does would actually be really useful in my network. So the network engineer will be responsible for going to the boss and saying, hey, let me tell you why I think we need this thing. Sell the boss on that, and then the network engineer will have to put in the purchase order and get that blade, get that module, order those cables. So that's something else the network engineer will do. Now, if you're starting out in the world of networking, you're not going to be doing either one of these two things, right? Both of these two things, the engineer and the architect, require years of experience before you get there. What you will probably start out doing, if you're fortunate, is working as the network administrator. So network administrator is in charge not only of a smaller scale network, but a lot of times network administrators have to do things that aren't even related specifically to networks. For example, being in charge of servers as well as the network infrastructure. So be aware of that you are going to be a lot more employable if on your resume you say, not only do I know Cisco stuff, routing and switching, but I also know how to set up email, Active Directory, DHCP. I know how to get a Windows or a Linux server up and working. Because a lot of times network administrators are expected to know both of those skill sets. So the network administrator has to be able to answer things like, is there space available on a server for users? If not, how do I create that space? Capacity planning, server backup plans, and creation and storage of user credentials, files, and directories. So this is all stuff that's server related that a lot of times network administrators also have to know. Now, in addition to that, when it comes to actual networking stuff, the network administrator will install and configure new equipment. So the equipment that comes from Amazon or directly from Cisco, they are the ones that will take it out of the box, screw it into the rack, plug in the cable, turn it on. They're the ones who will probably be told, here are the features you need to implement, here's what we need the feature to do, and we'll configure the feature to work. They will do the cabling of the equipment, so they'll have to know what the different types of Ethernet cables are, what the different types of fiber optic cables are, what the different connectors look like. And they'll have to implement change requests and implement upgrades. So somebody might say, hey, we're having some problems with router 1 and rack 6. We need you to swap that out. So you'll have to know as a network administrator, okay, you'll have to be able to look at a topology diagram and figure out where rack 6 number is in the data center or in the wiring closet, where the router is, router 1 that they're talking about, and you'll have to pull that thing out, put a new one in. You'll have to implement software upgrades. So these are all types of things that network administrators would have to do. Now, a lot of times, people have to start their career in networking as a technical support engineer. And this is actually a great way to learn networking. This is how I started at Cisco. I started in the Technical Assistance Center Technical Assistance Center, as a TAC engineer, which is a support engineer. So these people do phone support. So it might be internal phone support. Somebody calls in and says, hey, we can't get to this email server, or the internet's down. And so they'll have to troubleshoot that by remotely logging into devices. So they typically provide remote troubleshooting support. Technical support engineers, a lot of times, don't even get hands-on. For example, when I worked at the Cisco TAC, unless I wanted to go into the lab and play with stuff, I could have done my entire job for year after year, never having touched a router or switch. Simply taking calls from customers. You have to be very well versed at identifying the problem. A lot of times the way people are describing the problem is sort of navigating around the edges of it, and you have to ask some probing, very good questions to hone in on what the problem most likely is. So that's troubleshooting, right? You have to be able to do that. And then a lot of times, if you're fortunate, you can log into the router or switch remotely and fix it yourself. But for example, if you work in Cisco's TAC, a lot of times you don't have the privilege to log into customers' equipment. They don't want you doing that. It's secure. They want to tell you the problem. You have to listen to them. You have to ask them enough questions where you can diagnose what the problem is. And then you have to ask them for things. You have to know, okay, I want to ask them for the output of certain commands. They will then email me or something. And then when I look at that output, I can say, okay, I think this is the issue. And then you tell the customer over the phone or via email, this is the command I want you to type in. This is what I want you to do. So you might not even be getting any hands-on experience, but you know how the protocols work. You know the commands to troubleshoot and implement the protocols so you can help somebody else who does have access to the equipment get the thing running, get the thing working. So as a technical support engineer, you're not going to have any hands-on installation of equipment. That is the network admin that's going to do that. But it builds a great foundational knowledge of software and network operating systems. Also, another benefit a lot of times of being a technical support engineer is it gives you the ability to specialize. Like as I mentioned, if you are a network administrator, not only do you have to know things about networks, but they probably also want you to know things about servers as well. You might feel like as a network administrator, you might feel like you're running around with a chicken with its head cut off saying, well, I know a little bit about this and a little bit about this. I know a little bit about like thousands of things, but I never have the luxury of really learning any one thing in great detail because I'm always running around doing different stuff. Well, if you're a technical support engineer, there's a good chance that you might be able to specialize. You might be able to specialize in troubleshooting just routing protocols or just switching cases or just cases with security. So you have that opportunity to learn that in great depth and great detail. That's a benefit. That's a pro of being a technical support engineer. So what type of personality is right for these jobs? Number one, you have to be highly organized, right? Especially if you're working on multiple trouble tickets throughout the week, you have to be organized. You have to be able to organize your topology diagrams, organize all the knowledge that you're learning. You must enjoy learning new things. This is not a job for someone who wants to learn something and then just do that same thing day after day after day for years and just zone out like a zombie. That's not going to work. All right. So the world of network is never stop growing. There's always new stuff coming out. And so if you want to stay up to pace, up to date, you have to always be learning new things. You have to be willing to work off hours. Okay. So especially if you're in a role that involves troubleshooting, problems can happen any time of the day or night. So most of the time, you'll probably be working a regular shift. You have to be willing that every once in a while, you're going to be called in at 3 a.m. Every once in a while, you're going to have to come into work on a Saturday. And you have to be a critical thinker. You have to be good at troubleshooting. If someone coming to you, if their stress affects you, if they're stressed out because the network isn't working the way it should and they're freaking out, if that makes you freak out, you probably don't want to do this. You need to be able to listen to what they say and just ask critical questions, get the information, and be able to logically come to a good conclusion about the problem and how to fix it. You should be able to work well with others. You're going to have to work with other people, the people who are presenting to you the problems that are happening. The people that are saying, here's what we need to buy, go get it. The people that are creating the new network designs. You know, you have to work well with all these other people. And you're going to be able to sit in front of a computer monitor for extended periods of time. Some people, that's just not what they want, right? The idea of sitting in front of a computer screen for hours a day, they can't handle that. If that describes you, this is probably not the right industry for you. I also just want to talk real briefly about what type of pay scale for a network administrator you can expect. Now, like I said at the beginning of today, I said this is all based on the United States. So if you're in a different country, this won't apply to you, but this is in US dollars. So I'm just going to throw this stuff up here on the screen so you can see it. This is just taken from different websites. Oops, that's too fast. So you can see the range of salary for a network administrator is quite broad, depending on what website you're looking at. I went on today, before I did this class, I just really quickly checked out Indeed.com and Dice.com, and I just typed in the keyword of a network administrator, and it seemed like it was consistently pretty much, and I did it for my area, so I did it for Durham, North Carolina, not the whole US, and for where I live and work, it seemed like the average pay for a network administrator was somewhere in the high 50,000s to the mid to high 60,000s. Of course, there was stuff lower or higher than that, but that was sort of the median, that was sort of the average. So as a network administrator, this is what you can reasonably expect to start out with. All right, so I'd like to go into a Q&A section right here, and then we'll have one more section to look at. So let me see if there are any unanswered questions. What questions do you have for me? Somebody asks, is 4 years of networking experience and a CCNP routing and switching enough for a network engineer position? Honestly, somebody who's hiring specifically for a network engineer would probably be looking for CCIE. You might be able to get away with a CCNP. But to be a network engineer, I would probably say at minimum, you'd want to have 2 CCNPs. You'd probably want to have a CCNP in routing and switching and one other specialty, like data center or security or collaboration or service provider. But just one is probably not enough. You're close, but not quite there. Does someone need many years to get higher job roles such as network design or networking? Absolutely, absolutely. Once you get up to the role of a network designer and network architect, they're looking for more than certifications. They want to know that you have the experience. Somebody's asking the CCDA, is that a high-end course or something supplemental to the certs? So with Cisco certifications, you have the certifications that are designed for helping you learn how to implement networking, troubleshoot, and monitor networking. So that's your CCNA, NP, and IE, right? For your associate, professional, and expert. That's all for that. But if you want to get into the realm of design, right? They have a whole separate series of design certifications. So the CCDA is a Cisco Certified Design Associate. So that's the entry level. It's like the CCNA, but the CCNA does not answer the questions of which routing protocol is best, which feature is best. You know, if you want to answer the questions, which of the blank is best, your NA NP, IE is not going to answer that question. That's where you want to go for the design specialties. So the CCDA is the first one, then there's the design professional and the design expert. At the very top of the food level, of the food chain, is the Cisco Certified Architect, the CCAR. That is so incredibly hard to get. I think the last time I looked, there were like 15 of those in the entire world. You have to pay like, I'm not kidding you here, you have to pay something like $12,000 or $15,000 just to take that. And it's not just a written exam, you have to stand in front of like a panel of Cisco experts where they ask you questions. You have to verify and prove like your experience. That's why there's so few of them. But if you can get a Cisco Certified Architect, you're good. You're ready to make those huge big bucks. Somebody's asking, is it better to get multiple CCNPs or one CCIE? My typical advice to people is you definitely want to start with routing and switching, and you want to get a CCNA and a CCNP in routing and switching. At that point, you have a choice. If your real passion is to branch out, then that would be a good time to branch out. Then get your CCNA in security or your CCNA in wireless after you've gotten your CCNP in routing and switching. Or you could go one more higher to the expert level and get a CCIE. It's really up to you. I would probably recommend getting the CCIE. If you look at job offerings, CCIE is still very high in demand. And once you get your CCIE, then you can relax a little bit and take a little bit more time going back down and getting like a CCNA in wireless or a CCNP in security. But until you have that IE, it's always going to be in the back of your head, right? You're always going to see these jobs that say CCIE preferable, and you're always going to be thinking, man, I know I'm going to have to get that someday. I'm going to have to get that someday. So you might as well just get that. If you've already got the NP, you might as well just go for it and go for the IE and then branch off into some specialties. Someone's asking software engineer or network engineer, which one is better in the US? Now, please guys, correct me if I'm wrong or if your perception is different. My perception is there's actually more jobs in software engineering than in network engineering. Network engineering is expected to grow. It is I think I saw it was like 8 or 10% projected future growth. But I'll tell you, whenever I look at available jobs, it seems like for every one job title that says network engineer, there's like 5 that are like software engineer. However, I don't think software engineers get paid as much as a network engineer. So software, it's still a good paying job, but I think software engineers are more in demand, but it's a little bit less pay than a network engineer. Well, if you guys watching have different opinions on that, I would love to hear it. Do I know the main reason why CCIE lab fails are so high? I think I could tell you why. So once you get to the CCIE level, Cisco likes to throw at you a lot of corner case stuff. And what I mean by that is they want to know if you are familiar with and able to implement and troubleshoot stuff that you'll probably rarely see. Some of these features and protocols that were designed for very specific corner case scenarios, they're going to want you to know that. And also because at the CCIE level, there's so many things they could hit you with. I mean, if you take a look at the blueprint, it's just gigantic, the amount of things. So it's just the sheer quantity of things you have to know going into that exam, going into the lab, which I think causes such high failure rates. Let's just see if there's one more question I can answer here. Yeah, if you're looking for, so somebody says, I'm looking for something like, how should I number this network? Or, how, should I use VLSM or not use VLSM? That all falls into the category of design, right? What are some recommended design guidelines? What are some best practices? And that's all. Go talk to them. Ask them, what's your job like? What do you like about it? What don't you like about it? What did you do? How did you learn this? Where did you go to learn this stuff? How did you get this job? What's some stuff you wish you knew that you don't right now? If you were to hire somebody to help you, what types of things would you be looking for in that person? And maybe even suggest that they give you a roadmap as far as you say, hey, here's where I am right now. What do I need to get to where I'm able to do what you do? Watch YouTube videos where network engineers are interviewed. There's a guy on there called Eli the Computer Guy who specializes in interviewing people from various different jobs and just talking to them about their job. He asks them these types of questions. How did you start doing this? Why did you want to start doing this? What do you like about it? What don't you like about it? How would you recommend people move into this industry? So I would look him up on YouTube, and he's got a lot of network engineers that he has interviewed, which would give you a really good perspective. Next, you're going to want to start doing it. So I'd recommend that you purchase some gear. At an absolute minimum, I'd recommend you purchase 2 routers and a switch. You're not going to have to spend a lot of money on this. You can see a couple of 3725 routers you can get for as low as $80 each. A 3560 switch you can get as low as $100. So for less than $500, you can gear yourself up with a little small mini lab and you can start working on it. Now, why do I recommend getting physical gear as opposed to just starting with an emulator or a simulator like GNS3 or Packet Tracer? You're definitely going to want to do that as well, but there's a lot of benefits of having physical gear in front of you that you're going to need to know if you actually want to start working in this industry. For example, how to connect your laptop to console ports. You can read about it, but unless you actually do it, it's a whole different ballgame. LED status, right? Looking at a router or switch and understanding when the LEDs change colors. What triggered that? What do those different colors mean? Cabling experience. Learning that, oh, an RJ45 jack. Gotta be real careful if that little connector snaps off, that little security connector, now the thing can just pull right out. Getting experience with upgrading Cisco software. That's different on different software. Saving and loading remote configs, password recovery, sniffer traces. These are all things that you can't really do on remote equipment. Now, some additional stuff. Another benefit of buying a 3725 router is because sooner rather than later, you're going to want to get a hold of GNS3. Let me show you that real quickly. So if you go to GNS3, just go to gns3.com. I'm going to expand this to make it a little bit bigger so you can see it. So GNS3 is free software. You can see here, free download. And once you download GNS3, I'm going to go ahead and start it up here. Now GNS3 is actually paired with Cisco iOS software. So you have to have a real Cisco iOS software image to work with GNS3. But the beautiful thing of this, let me go ahead and start up here real quick, is that once you've got the free GNS software and once you've got a Cisco iOS software image that will work with GNS3, you can create topologies and practice on these topologies without actually having real physical routers or switches. Let me see if I can open a project here, for example. Well, I'll show you what the front end looks like. I'm not going to take a lot of time going through this, but this is the front end of GNS3, and you can drag and drop routers and switches in here. You can connect them up, and then these things are running real Cisco iOS software, and so you can practice this stuff. Now, how does that relate to what I mentioned earlier? One of the software images that the GNS3 works with is a 3725. And if you get a physical 3725 router, which you can see here is pretty cheap, then you can take that same software that you bought and paid for and import it into GNS3. And that particular router can also do switching. So you can practice routing and switching to a certain degree. Switching's a little limited, but routing you can do everything. So that's a big reason why I suggested that particular model of router, because you're going to extract the software from it and use it in GNS3. Some other things you want to get a hold of are Packet Tracer. Packet Tracer is also free. If I go to google.com and type in Cisco Packet Tracer, you'll see here you can download it from Cisco's Network Academy. And then Packet Tracer is also great for practicing routing and switching, getting really familiar with the commands. For the CCNA level, it's awesome. And let's see here. Was there anything else I wanted to mention? Oh yes, also one additional thing is, even though I would recommend that you, when you're starting out, get a couple of routers and a switch, like I said right here, at some point you're going to want to start creating labs that have real routers and real switches. For example, when you get to the CCNP level, GNS3 and Packet Tracer doesn't cut it when it comes to switching. Routing, yes. Anything you want to do with routing, you could do in GNS3 all the way up to the CCIE level, but switching, not so much. To start getting familiar with the intermediate to advanced level of switching concepts, you really have to have access to a minimum of 3 or more physical switches. Now you could buy the physical switches, or you could rent some time on some racks. So let me talk just briefly about INE's rack rentals, because this is also something that I think would be useful to you. So if you go to the members account, members.ine.com, you will see that one of the things that we offer up here at the top, it says rack rentals. And if you click on that, we actually have our own data center that has racks and racks and racks of equipment. And you can rent time on this equipment. Now starting out, if you're going for your CCNA or your CCNP in routing and switching, you probably want to rent some time on the CCNA routing and switching racks, which consists of 4 physical routers, 3 physical switches. Everything's already pre-cabled for you. And this only runs $3 an hour. You can see it's 3 tokens per hour. So what you initially do is you purchase tokens. And you can see you can get as little as 100 tokens to start with, and then it goes up from there. But the list price of a token is $1. So if you're buying 100 tokens, that's $100. The more you buy, the bigger of a discount you get. And then once you've got your tokens, you go back, you select a rack you're interested in, like for example, the CCNA, CCNP, I'll just click on schedule. And maybe I say, okay, this Saturday, I want to spend 3 hours practicing some of these more advanced routing and switching concepts. So for that, I'm going to see this Saturday here is going to be what? The 18th night, this is going to be the 21st. So I'll click on the 21st. I want to do this from, let's say, 9:30 a.m. until the 21st at, let's say, 12:30 p.m. And I click search, and I can see, okay, those 3 hours are available to me. So I would just click on book right now, and I'd have 3 hours reserved on a particular rack. I will get an email that will tell me what my username and password are to log into that rack. And then I can practice those routing and switching concepts on this rack. And you can also see here that we had other racks available as well. We've got CCIE level racks for routing and switching, for data center, for collaboration, security. Just depends on what you need. So this is also a great way to get experience with real live equipment if you don't want to pay for it yourself, don't want to pay to actually buy the equipment. And the last thing I want to talk about real quickly are the certifications. And I think I've already mentioned this basically. So Cisco certifications, the very first sort of entry-level certification is the CCT, the Cisco Certified Technician certification. We have a series of videos on that. And then from there, the next one up is the CCENT, Cisco Certified Entry-Level Technician. Just one exam to pass for that. And then you go up to the CCNA. Pass. So once you've gotten your CCENT, pass one more test, you got your CCNA, and then you go up to the professional level certifications. So all of the professional level certifications, whether you're talking about routing and switching or one of the specialties, are a minimum of 3 exams. For example, the CCNP in routing and switching, you have an exam called switch, an exam called route, and then an exam called T-shoot for troubleshooting. Some of the other NP exams have 4 exams to get the certification. And then you go up to expert, and then if you're really gung-ho, you can go up to architect and try that. And I already talked about the design specialties. Let me show you where you can get more information about these certifications in case you want to pursue that. So I would recommend just going to our good friend Google here. And let's just type in Cisco CCT to begin with. Technician. So from here, if you just click on certifications, you can see it talks about all the different certifications. You can click on any one of them. For example, let's just do the professional level in security, CCNP security. And you can see here, it says, well, to get the CCNP security, you have to have a CCNA security or a CCIE. Those are the prerequisites. So you can see what the prerequisites are. It shows you have to pass 4 exams. If you click on any one of these exams, for example, if you click on the name of the exam, like it here, it'll take you to a page where you can purchase training content, or where you can actually go to take the exam. Or if I go back, if instead of clicking on the name of the exam, I click on the number, the exam number, like this one right here, it'll give me information about the test. It'll tell me how long it is, how many questions, and then for any of these, you would click on where it says review the exam topics. And this takes you to what's called the exam blueprint page, where you can see, okay, these are the high-level topics, and if I click on details, this shows me under threat defense the particular topics that they'd want me to know that I could be potentially tested on. So I just spent some time going through these for any one of the exams you're interested in. So that concludes what I had to say in this presentation today. Let me just go back real quickly and look at the questions and see if there's any more questions we can finish up on here. Yeah, Viral, Cisco's Viral is interesting. So Viral, the virtual internet routing lab, you pay for a subscription. It's a 1-year subscription. And with Viral, you get to access these remote servers and you get to build virtual router and switch topologies on these virtual servers. Now, if you're at like the CCNP or higher, if that's the level that you're at, if you're already beyond the CCNA and you're now starting to go for your CCNP or higher, Viral's fine. But, you know, if if you're watching this class because you were thinking, I don't know anything about networking, I'm just trying to figure out, is that a direction I want to move into? Is that a career I want to do? And most of the stuff I talked about today was brand new to you. You probably do not want to pursue Cisco's Viral. Number one, it's very complex to get working. It's not easy to get it up and working. It assumes you already have a lot of knowledge about servers and stuff just to get the thing working. And number two, switching is still very limited. They use a flavor or a form of IOU for switching, and a lot of even the CCNA level stuff like port security. Port security is a feature that switches can do. You have to know it for the CCNA. You can't do it in GNS3. You can't do it in Viral. So that's why I'd recommend stay away from Viral at the CCNA level. It's overkill. It's too complex to get working, and you can accomplish your objectives a lot easier with just Packet Tracer to do that. Yeah, and as far as the Cisco exams are concerned, if you fail the exam, you can retake it. They typically have a policy, it depends on the exam, but most exams, if you fail an exam, you have to wait a minimum of like 15 days, I think it is. It's either 15 or 30 days before you retake the exam. But you do have to pay, right? Most of these exams are anywhere from $165 on up. For example, the CCNA exams, I think are like $165 or $170 to take those. The more advanced exams are more expensive. So if you retake it 10 times, Cisco would love to have your money because each time you're going to have to pay the full fee. There's no discounted fee for a retake. So just be aware of that. And once you do pass a Cisco certification, you do have to recertify. Most of the exams are good for somewhere between 2 and 3 years, and then you have to recertify again. So someone's mentioning about IOU with IOU 15.x, and as far as switching is concerned, here's the main problem, is that a lot of switching features, once again, not necessarily stuff you have to know at the CCNA level, but a lot of switching features are implemented in hardware, not software. So for those of you who don't understand the difference, let me explain that real quickly. So both routers and switches have a processor, right? Like your laptop, like your tablet has a processor, and they're running software. Like on your laptop, your processor is running Microsoft Windows or Mac OS or whatever. So in routers and switches, their processor is running Cisco iOS. So in routers, the vast majority, like 90% of all the things that routers do is run on that processor, run in software. So you can take that software as IOU, put it on a server, and still get access to those same features. It's not the case with switches. With switches, there are several features that are done in software, but a lot of other features are optimized in what we call hardware, which means they build special circuits, special ASICs, and the features are done on those ASICs, on those circuits. They're not done on the CPU, they're not done in software. The software might be able to program the ASIC, but the ASIC itself is doing the feature. Well, when they took that switching software and they converted it into IOU, or what they call L2 IOU, that only supports the features that that software could do. The things that the ASICs could do are not in L2 IOU. So that's, as far as I know, that is still a downside. Nobody has figured out a way around that yet. Any other questions? When will Brian McGann become a CCAR? Good question. You'll have to ask him that. I'm sure he would love to do that. I'm not sure he wants to fork out the $15,000 to try, though. Yes, as far as recertifications or refreshes are concerned, how's that work? In many cases, for example, if you take a higher level test, like let's say, for example, right now, you got your CCNA. I think the CCNA is good for 3 years, I believe. So let's say you got that 2.5 years ago. So you're thinking, okay, in about 6 months, I'm gonna have to retake the CCNA again. Or if you take a higher level test, if you take, for example, a CCNP and you pass that, that automatically recertifies all your lower level exams. Also, a lot of times when you take a test, it will recertify any test you have at that same level. For example, a lot of these people who've got 3 or 4 CCIEs, the CCIE is good for 2 years, and then you have to recertify. Well, you might think, man, if I get 3 CCIEs, does that mean every 2 years I got to take 3 of those tests? No, you don't. You just have to take one of those CCIE exams, recertify in that, and it automatically recertifies your other CCIEs, as well as everything else below that that you had. So that is a nice perk that Cisco has. Someone's saying they hold a CCNP certification. They're working as desktop support. What would I suggest is the next level job field? I'd recommend that you pursue network administrator. Try to get into the network admin field. That's where I'd go from there. Does INE have a CCIE data center training course, and how do we do it online? Yes, we absolutely do. One way you can tell what courses INE has without actually buying them in advance is you could go to your members dashboard. Remember, to get an account on the members is free, just requires your username and email address. And then from here, click on where it says All Access Pass. And you'll see if you had an All Access Pass, these are all the things that would be available to you. Now, if you're specifically concerned with CCIE Data Center, you could just click on Cisco, CCIE, Data Center, and you can see we have a lot of stuff on CCIE Data Center. And I think you can even click on these without an All Access Pass and get to this level right here, where you can see the topics that are covered in any particular course. And some of our courses, not all of them, the very first video sometimes is free. It's like there's like a preview. So you could try that as well. But like I said, even without having paid for anything, you should be able to get to at least this level here so you can see what particular videos are included in a course and the title and the duration of each of those videos. And yes, we also have boot camps. Let me mention that as well. So here at INE, my specialty is in the CCNA and the CCNP level of routing and switching. And I offer boot camps in that as well. So a boot camp is where you would come from my boot camps. You would come here to the Research Triangle Park in North Carolina. If you're taking a CCNA boot camp, you would be with me for 5 days. CCNP boot camp, you have 3 choices. I have a 7-day CCNP boot camp where I cram route and switch into 7 days. Then I also offer 2 separate boot camps. I offer a 5-day route and troubleshooting boot camp and a 5-day switch and troubleshooting boot camp. So the general experience is for any of these, you show up, you would stay in a hotel that's local here, and then class would begin at 9 a.m. in the morning. And throughout the class day, I will be presenting on different topics. I'll be whiteboarding the topics. Of course, I'm available to answer any questions, so students are frequently, interrupting me and asking me questions, which I love to do. Keeps it interactive. And there's also labs. Throughout the day, I'll say, okay, so we just learned about EIGRP authentication. Let's do a lab on it. And so you'll be given a lab workbook where you'll work through the lab, And then after a certain amount of time, I'll work through the lab and I'll say, okay, so step number 1, here's how we would have done this. Step number 2, here's how we would have done this. While you're doing the lab, if you have any questions or problems, Keith, can you come over here and take a look? And I'll come over there and help you out. I also have frequent quiz questions during my boot camps where I'll stop and I'll say, okay, John, what do you think is the answer to this question here about VLANs? Sally, what's this question here about EIGRP? So there's a lot of interactivity, there's a lot of feedback. The days are very long. There's a reason why we call it a boot camp. So my boot camps typically start at 9 a.m. and end at about 7 or 7:30 p.m. And of course there's breaks for lunch and stuff like that as well. But it's very intensive boot camps that we have here. And then we also have other instructors who give CCIE level boot camps. We have CCIE Data Center, CCIE Routing and Switching. So all of that is also available. And you can just go to ine.com. And here from our main page, you can click on where it says here boot camps. And you can select the various boot camp. For example, there's a CCNA boot camp coming up fairly soon, I think. Let's just see here. Yeah, so November 13th is my next CCNA boot camp here in the Research Triangle Park. I would love to have you here. I'd love to see you. As far as the Bay Area, every once in a while, INE will send me to San Jose. Actually, I was just in San Jose a couple weeks ago delivering a 2-week stretch of a CCNP switch and a CCNP route boot camp. So about once every 3 or 4 months, I do get out to San Jose to teach either the NA or the NP. I don't teach any of the IE level stuff. So if you're curious about that, I would just click on, so you mentioned CCIE Data Center. So I would just click on CCIE Data Center. And you can see that right here. I would click on View. And yeah, in December, we have a CCIE Data Center bootcamp coming up in San Jose, California. So it looks like we do those about every 6 months in San Jose. Okay, somebody else is asking if, let's see here. I don't do any of my boot camps. Let me rephrase that. We do have recorded a CCNA boot camp and a CCNP boot camp, but it's not the same experience as if you attended it live. So for example, if you watch my series of videos on the CCNA boot camp, as an example, in those videos, I talk about the technologies, I have PowerPoints, I have whiteboards about those technologies. When I did it, that was live, so there were, like you guys, there were people who were watching it who could ask me questions. So in those recordings, you'll see me as I answer people's questions. And then I do demonstrations. I say, okay, I'm going to go ahead and configure OSPF. I'm going to configure spanning tree. So I do that. But you're not doing it. I mean, you're watching the video, but you're not actually doing it yourself. And that's the big benefit of coming to one of INE's live boot camps. We give you time on our racks during that week. So if you come to my CCNA boot camp, not only are you hearing me and watching me talk, not only do you have the opportunity to ask me questions right then and there, but during that entire week, you have 24/7 access to a rack that's dedicated just to you. So during class time, you're doing labs on that rack. You can get my help if you get stuck. After class is over, you can go back to your hotel, eat a quick dinner, and then back in your hotel room, you can practice some more on that rack. It's all yours for the duration of that boot camp, which you're not going to get that by watching a video. And right now, I don't offer anything similar to that online. Now we are, I'm not sure if our calendar here goes out to next year or not. Let me just look for something real fast. CCNA boot camp. We were tossing around the idea of maybe next year doing a CCNA boot camp that was online, where basically, I'm not sure how much we would charge for that, honestly, but you would pay some fee, you would get a spot, and then from your office, from your home, you would watch me, much like you're doing right here. I would go over the material, you could ask me questions remotely. You would also be assigned a rack. So, during that boot camp, I would say, okay, let's take a break and I want you guys to do the EIGRP lab now. Here's the instructions, go for it. And while you were doing the lab, if you had questions, you could type in your question and I would help you out. So it'd be very similar to the experience of attending a live boot camp here with me. It's just, it would be remote. Have not done any of those yet, but we are thinking of possibly doing that next year in 2018. So just stay tuned for that. Let's see, what other questions are there? Yep, unfortunately you missed me in San Jose. So the next time I'm scheduled to go to San Jose is in January. That will be for one of my 7-day CCNP boot camps. So I'll show you where that is. I would love to have you there. So if you click on CCNP boot camp, that's going to be the 7-day one, which is this one right here. Yeah, so you can see right here, that's going to be January 22nd. Actually, it's through the 29th, not through it's 7 full days. So I don't have a calendar here in front of me, but it starts on a Monday and it ends actually on a Sunday afternoon, 7 straight days, and that will be in San Jose, California. Okay, so I think that will end it for today. I'm going to go ahead and bring this session to a close at this point. I hope this was beneficial. I hope this was useful to all you guys. We'd love to have your feedback. You've got my stuff there to reach out to me. And I appreciate you guys all tuning in and watching today. So good luck on your networking careers. I'd love to hear from you. Please, I so rarely get feedback from folks. So, let me know as you pursue your career in networking. Let me know, what did you find helpful? What certifications do you find that people are asking for out there in the real world? What's been your experience as far as job employment and stuff is concerned? I could take all that stuff and incorporate it into future classes, so I'd love to hear from you. So with that, I'm going to go ahead and fade to black at this point, and I hope you guys all have a great rest of your week. And thank you for tuning in. See you later. you.